a shocking theory claims that mysterious comet Oumuamua might be a von Neumann probe, an alien spacecraft with broken engines tumbling through our solar system. It sounds extremely unsettling, but first things first, what is a von Neumann probe? Mathematician John von Neumann suggested the concept of self-replicating spacecraft that could in some ways mimic the features of living organisms or viruses. People started to refer to such hypothetical spacecraft as von Neumann probes. Von Neumann was sure that using self-replicating spacecraft would be the most effective way to perform large-scale mining operations, like mining asteroid belts or moons. The creators of such probes could take advantage of their exponential growth. Hypothetically, a self-replicating spaceship could be sent to a neighboring planetary system and look for raw materials there. Such materials could be extracted from moons, gas giant planets, asteroids, and the likes. Using these materials, the probe could make replicas of itself. The replicas could then be sent to other planetary systems, and the original probe could pursue its main purpose within its parent star system. This pattern sure does repeat the reproduction patterns of bacteria. That's why some experts think that von Neumann machines could be considered a form of life. There's also a theory that a self-replicating spacecraft could spread throughout a galaxy the size of the Milky Way in just 500,000 years, even if it used conventional theoretical methods of interstellar travel. In other words, it wouldn't even need to employ exotic faster-than-light propulsion. In 1981, mathematical physicist and cosmologist Frank Tipler argued that extraterrestrial intelligence couldn't exist because people had never observed von Neumann probes. Even if we take a moderate rate of replication, such probes should already be common throughout space. So, it's really weird that we haven't come across any of those yet. It might only mean that extraterrestrial intelligence doesn't exist. A response to Tipler's arguments came from astronomers Carl Sagan and William Numan. They pointed out that Tipler might have underestimated the rate of replication, and von Neumann probes should have already started consuming most of the mass in our galaxy. Therefore, any intelligent race would avoid designing von Neumann probes in the first place and try to destroy any probes as soon as they found them. Another objection to the prevalence of von Neumann probes is that civilizations that could potentially design such devices have an extremely high probability of self-destruction before producing such a machine. In any case, the assumed capacity of von Neumann probes is unlikely in reality. But then, how about Oumuamua? These days, scientists are using high-tech scanners to examine a huge, cigar-shaped comet, which might or might not be an alien probe. One idea is that it's an extraterrestrial civilization spacecraft, with broken engines wandering through our solar system. If that's the case, the object could easily be a von Neumann probe. Dr. Jason Wright from Penn State University thinks that a broken alien spaceship could move in exactly the same way as Oumuamua. Rather than moving through space like other space rocks, the 1,318-foot-long, 118-foot-wide space traveler is tumbling through the solar system. At the moment, it's traveling at a speed of around 200,000 miles per hour. In his blog, Dr. Wright says that if such derelict craft were not traveling fast enough to escape the galaxy, they could thermalize with the stars and end up drifting around like an interstellar asteroid or comet. They wouldn't have attitude control anymore and would eventually start tumbling. And it could distinguish them from regular interstellar asteroids. Plus, even though their propulsion was broken, their radio transmitters could work just fine. In any case, so far, it's just a theory, and further research is needed. What do you think? Is Oumuamua just a space rock or an alien space probe? One of the best and most convincing pieces of evidence that extraterrestrial civilizations have visited Earth could be the epic Nurmberg space battle of April the 4th, 1561. It was recorded either in 1561 or 1566. Different sources provide different information. All the retellings of this story focus on the woodcut picture and a vague summary of events that occurred that day. The emphasis is always on crashed spaceships and space battles. Almost everywhere you read or hear the story,
It goes like this. The inhabitants of the city woke up early on an April morning and saw a staggering celestial show that looked like a real space battle. This story sounds even more convincing when you find out that some objects allegedly fought for quite a while. And some even crashed. You can see them in the lower right corner. Look at the picture once again. Orbs and crosses fighting, a giant arrow and bizarre tubes, crashing ships. Wow, that had to be a spectacular cosmic battle. To make it all more plausible, Hans Glaser, the artist behind the woodcut, was a very real person. He really did woodcuts, and this one is indeed from the time and place that it says it is, meaning it's not fake, and it does depict a real event that had its own witnesses. For all intents and purposes, it looks like very convincing proof of aliens visiting us, but don't get your hopes up. A superficial perusal of facts seems to confirm an extraterrestrial presence on our planet. But the most likely explanation is much more mundane. The Nurmberg 1561 UFO battle is just an atmospheric phenomenon called a sundog, or parhelion. A sundog is a concentrated spot of sunlight that can sometimes be seen to the right or to the left of the sun, or even on its both sides simultaneously. Sundogs often appear as a pair of patches of light with subtle colors at the same altitude over the horizon as the sun. They can have a variety of forms, from colorful spots to patches of light so intense and bright, it looks like there are 2 additional suns in the sky. Sundogs are weird looking enough to make it seem that something scary and otherworldly is going on in the sky. At the same time, it's just our planet's atmosphere or ice in the upper parts of the sky acting as a prism or reflective device. This prism makes the light from the sun or moon do weird things. This image can help you visualize the phenomenon. Apparently, Nuremberg had the perfect conditions for this phenomenon to occur. If you examine the depiction of this event and compare it with modern pictures and videos, you'll soon realize that a sundog is indeed a more likely explanation than the galactic empire paying us a visit. Let's find the proof of this statement in the translated description of these events and in the woodcut picture itself. First, the sun showed and was seen with 2 blood-colored half-round strokes, like the diminishing moon right through the sun, and in the sun, above, under, and on both sides, stood blood-colored and partly bluish, or iron-colored, also black-colored round orbs. Now here's the photo of a sundog. It has a halo surrounding it, and a red orb. And if we have at least 1 red orb, there could be others showing up during other events. Plus, keep in mind that sundogs are like prisms. So, depending on how light is reflected, there could be multiple colors present during such a phenomenon. Now, referring to circled plates mentioned in the description, those could be halos. For example, this sun halo looks vaguely plate-like, and it seems to be linked to other sun halos. And indeed, people have seen halos with multiple orbs. Some of the orbs could have taken a cross-like shape. If we watch some modern videos of sundogs, we might notice that the orbs on film are sun-colored. But since the Nuremberg event happened between 4 and 5 a.m., the clouds and the sun could have had reddish and orange hues. As for the fighting, it could be as simple as one shape moving a bit and changing shape along with the movements of the sun. It could have looked as if it was pushing the other shapes out of the way. Do you agree with the scientific explanation? Or do you prefer to think that Earth was visited by guests from a galaxy far, far away? Write your opinion in the comments. In the middle of the previous century, flying saucers were constantly making headlines. America was going through a surge of reported UFO sightings. So, it shouldn't probably come as a surprise that the American authorities, namely the US Air Force, created a couple of short-lived programs. Those were Project Sign and Project Grudge, and their main goal was to look into that phenomenon. These programs were followed by likely the most famous of them all, Project Blue Book. It was a large-scale government study that lasted from 1951 to 1969. The initiator of this program was Major General Charles P. Cabell. He was a former intelligence director of the Air Force. Project Blue Book scrupulously gathered over 12,600 reports about people seeing bizarre, unidentified objects in the sky. After thorough research, it was determined that most of those had natural, quite mundane explanations. As for the rest of the reports, the members of Project Blue Book simply didn't have enough data to evaluate them. That's why support for their efforts dwindled. Officially, Project Blue Book was closed in December 1969. But apparently, it didn't make American authorities lose interest in UFO sightings. Because in mid-December 2017, the world found out that they had secretly launched one more UFO research program in the late 2000s. Accordingly to certain documents, American authorities spent around $22 million over a 4-year span on a project called the Advanced Aviation Threat Identification Program, aka AATIP. This project was started in 2007, and its main goal was to study UFO phenomena. Most likely, all this activity was triggered by the 2004 Tic Tac incident. That's when a few U.S. Air Force pilots spotted unidentified flying objects off the coast of California. They captured them on video. None of the pilots could figure out what these objects were. They behaved in a weird way, as if our laws of physics didn't apply to them. They were reportedly flying extremely fast and rotating in unpredictable movements. It looks as if after that incident, American authorities decided to investigate whether those objects could be identified or not. And if not, they were eager to know where they had come from and if they had been a threat. When the New York Times story about the new project broke, officials announced that the study had been terminated in 2012. However, there were people who claimed that the program was still ongoing. One of those was a military intelligence official running the program until they quit in October 2016. In any case, let's have a closer look at this mysterious program. Indeed, the areas of research funded by the project resembled things you could find in Star Trek. For example, one grant was for the study of traversable wormholes, stargates, and negative energy. This study was conducted by Eric W. Davis of EarthTech International, Inc. Another grant sponsored the research of invisibility cloaking. One more area of study included warp drive, dark energy, and the manipulation of extra dimensions. This research was conducted by a theoretical physicist and director of the nonprofit Icarus Interstellar. As we've already mentioned, all these studies received at least $22 million of funding, but this sum could have been much bigger. No one has revealed why or how these studies were given such huge grants under the AATI program. The results of the study aren't known publicly either. The criteria for choosing these fields of research could be that warp drives and stargates might be useful for extraterrestrial civilizations traveling interstellar distances to visit our planet. Still, some people are not amused that such questionable fields of study were receiving substantial government funding.
The Roswell Incident is a collection of events and myths surrounding the crash of a mysterious object in 1947. Right after rubber and metallic debris was recovered by Roswell Army airfield staff, the United States Army claimed that they had their hands on a flying disc. Just a day after this announcement was made and made international headlines, it was retracted, but the word was already out. To hide the true nature of the find, the Army stated it was a good old weather balloon. But later in 1978, a retired Air Force officer revealed that it was just a cover story. At the same time, he added that he was sure that the debris had an extraterrestrial origin. This speculation became popular thanks to the 1980 book, The Roswell Incident. It also turned into the basis for long-lasting and increasingly contradictory and complex UFO conspiracy theories. Over time, they expanded the incident to include authorities hiding the evidence of other space civilizations, multiple crashed flying saucers, alien bodies, and even reverse engineering of extraterrestrial technology. However, none of those theories were based on any real evidence. But despite the absence of proof, many supporters of the UFO theory claimed that the Roswell debris was from a crashed alien craft. They accused the authorities of creating cover-up stories. This conspiracy narrative became a trope in movies, science fiction literature, and TV shows. No wonder that the town of Roswell is still promoting itself as the best destination for UFO-associated tourism. But what happened in this area in reality? The government's claim that a weather balloon had crashed at Roswell was indeed a lie. In 1994, the Air Force admitted that the recovered debris had actually been from an American balloon used to watch other nations. It was part of Project Mogul, an attempt to monitor anticipated nuclear tests that could be conducted by other countries. In 1997, an Air Force report called the Roswell Report, Case Closed, suggested that all those stories about alien bodies could have come from civilian witnesses who had seen parachute crash test dummies. The report also suggested that the witnesses might have combined several different events in their memories: the Project Mogul materials, the crash of test dummies, and a few other accidents that had occurred in the area. For many supporters of the UFO theory, though, those explanations sounded like the authorities planned to cover up their interaction with extraterrestrial civilizations. After all, in 1947, the USA, as well as some other nations, was in the midst of the flying saucer craze. People reported seeing bizarre objects in the sky. They claimed those were spacecraft piloted by aliens. It was against such a hectic background that a rancher discovered some highly unusual debris near Roswell, New Mexico. The material included tinfoil, sticks, and rubber strips. The next month, he took his findings to the Roswell sheriff. The man contacted the Roswell Army Airfield. After getting the wreckage, they issued that very extraordinary press release claiming that a flying disc had been found at a local ranch. The reasons for such an outrageous statement were unclear. In any case, the Roswell Daily Record picked up this press release right away, printing the story on the 8th of July with the headline, "RAAF captures flying saucer on ranch in Roswell region." That's when the military backtracked, announcing that it had been just a weather balloon carrying a radar target. That's a device that looks like a box kite made of foiled paper fastened to a balsa wood frame. The Roswell Morning Dispatch paid attention to this new claim and released a new story called "Army Debunks Roswell Flying Disc as World Simmers with Excitement."
It was the year 1952 when America first caught the flying saucer fever. A rash of strange sightings was reported in the skies over Washington, D.C. Were those unexplained radar blips, unidentified aircraft, or something much more outlandish? The Washington, D.C. sightings of the summer 1952 are also known as the Big Flap. But it all started in 1947 when a search and rescue pilot reported 9 saucer-like things flying like geese in a diagonal chain-like line. Their speed reportedly exceeded 1,000 miles per hour. Within mere weeks, the sightings of flying saucers were reported in 40 other states. Later, the explanations were found. The sightings were either hoaxes or misidentifications of known aircraft and natural phenomena, but a few cases remained unexplained. By 1952, the UFO investigation unit called Project Blue Book had been founded. It was led by Captain Edward Rubbold. He and his team would have continued to investigate a few dozen sightings per month, but for the April 1952 issue of Life magazine with an eye-catching headline, "There is a case for interplanetary saucers." The article made quite a convincing case. It spoke about 10 unexplained UFO incidents, claiming that the flying objects were extraterrestrial in origin. According to the Washington Post, after the appearance of the article, the number of UFO sightings grew more than sixfold, from 23 in March 1952 to 148 in June. By July, the UFO mania was in full swing. All that was missing was a spark. And it happened before midnight on Saturday, July 19th, 1952. An air traffic controller at Washington National Airport spotted 7 slow-moving objects on his radar screen. They were far from any civilian or military flight paths. He called his supervisor and joked about a fleet of flying saucers. Simultaneously, 2 other air traffic controllers at National spotted a bizarre bright light hovering in the distance. It suddenly dashed away at breakneck speed. At Andrews Air Force Base, located nearby, radar operators detected the same unidentified blips. Those were slow and clustered at first, but then they raced away at a speed higher than 7,000 miles per hour. One Andrews controller looked out of his tower window and spotted something he later described as an orange ball of fire with a tail. A commercial pilot flying over the Virginia and Washington, D.C. area saw 6 streaking bright lights resembling falling stars without tails. 2 jets were sent to search for the UFOs, but every time they got close to the locations shown on the radar screens, the weird blips would disappear. By dawn of July 20th, the objects were gone altogether. Ruppelt, the lead investigator of Project Blue Book, found out about the sightings just a few days later after flying to Washington, D.C. and reading news reports. He tried to get to National and Andrews to interview the radar operators and air traffic controllers, but wasn't allowed to take a government-issued car. He had to fly back to Ohio with nothing. In a few days, UFOs were back over the Capitol. The same radar blips appeared again. Radar operators were wondering whether those dozen or so objects could be caused by a temperature inversion. That's a common occurrence in DC's muggy, scorching summer months. It occurs when a layer of warm air forms in the low atmosphere. It traps cooler air beneath. In this case, radar signals can bounce off the layer at shallow angles and create an impression of near-ground objects in the sky. To be safe, 2 more aircraft were sent to chase down the unidentified targets. The jets raced to a location targeted by radar, only for the blips to disappear. Eventually, one of the plane pilots saw a bright light in the distance and gave chase. But even though he was flying at maximum speed, he didn't manage to overtake the lights. At a press conference, representatives of the Air Force offered the public some easy-to-swallow explanations, having opted for the temperature inversion theory. After that, UFO sightings dropped from 50 a day to 10.
According to the theory of panspermia, life could have been brought to Earth by a meteorite, comet, or asteroid from a different region of space. At the moment, this idea remains purely theoretical. But let's figure out if it could actually turn out to be true. Traditionally, exobiologists, those who are focused on searching for life outside Earth, have been trying to explore the possibility of life on Mars or in the subsurface oceans of Saturn's and Jupiter's icy moons. But simple life could be much more widespread. It could be drifting through interplanetary space right now, in the form of dormant bacteria and spores. Several scientists have noted that the ultra-harsh environment of space is likely to severely damage the DNA and RNA of such spores and microorganisms. Others believe that since enough microbes could be traveling in a dust cloud, some of them could survive in their original form. There are several types of panspermia. For example, lithopanspermia proposes that some kind of microbic life could exist in debris blasted into the cosmos after planetary collisions with comets and asteroids. Radiopanspermia claims that organisms might be able to travel through space with the help of radiation coming from stars. But in this case, it's unclear how the effect of dangerous ultraviolet and X-ray radiation, combined with the vacuum of space, doesn't totally destroy microorganisms. There's also pseudopanspermia. According to it, organic building blocks of life appear in interstellar clouds of dust. They get transported to the surfaces of planets, and life starts developing there. It sounds really fascinating, but is there any evidence for the panspermia theory? Well, there have been a few orbital experiments. For example, from 2008 to 2016, the samples gathered by EXPOSE, special equipment mounted outside the International Space Station and dedicated to astrobiology, were exposed to the conditions of space. After that, they were returned to Earth from the ISS. It turned out that some of them had survived those severe conditions. There was even a case when 100% of bacterial spores placed in Mars-like conditions were still capable of life. Also, some seeds survived and were later grown as plants on Earth. There have also been exostack experiments on the U.S. Long-Duration Exposure Facility satellite and biopan experiments on Russian photon capsules. They have shown that with minimal protection, spores, lichens, and even minuscule animals, such as tardigrades, might be able to survive in space for as long as several years. A piece of Surveyor 3 lunar lander was brought back to Earth in 1969 by the Apollo 12 mission. Shockingly, it contained an Earth bacterium that had survived unprotected for more than 2 years on the airless surface. At the same time, this bacterium could have come from laboratory contamination on arrival back on Earth. The Indian Space Research Organization carried out a search for space microorganisms too. It was done at stratospheric altitudes via balloon flights. The results showed that living interplanetary cells existed in air samples taken from heights of above 25 miles. Normally, air from lower levels of the atmosphere can't be transported there, so this discovery seemed to prove the theory of panspermia. But in 2010, NASA atmospheric sampling before and after hurricanes proved that under certain circumstances, Earth bacteria could actually be transported very high into the upper levels of the atmosphere. One of the main arguments against panspermia is that if this theory was correct, all life found throughout the solar system would have a common origin and share main biochemical characteristics like genetic code. It doesn't sound plausible. Many specialists believe that only the presence of astronaut explorers on the surfaces of, let's say, Mars, Europa, or Enceladus can properly solve the question of life in the solar system. They can compare any life forms found with Earth-type life, which can turn out to be a real test of panspermia. In any case, until probes finally find direct proof of spaceborne life, the panspermia theory will remain unproven. If alien life exists, it may be way stranger than we can imagine. For some inexplicable reason, we've long assumed that aliens might be like us humans. But in reality, they're more likely to be some form of unfathomable AI. With dozens of billions of years of evolution, intelligence can develop in entirely new, unexpected directions. Humans might be near the end of Darwinian evolution. We no longer need to remain the fittest to survive. But the technological evolution of AI minds is just starting. Who knows, maybe in another century or two, we'll be overtaken by inorganic intelligence. So, the question is, are aliens more likely to be flesh and blood, like us, or are they something more artificial? Even though many believe that people are at the peak of intelligence, it's possible that our species may just represent a stage on the way toward more artificial and advanced minds. And it can actually explain why space seems to be empty of similar forms of life. Perhaps an evolutionary transition to non-organic intelligence is inevitable all over the universe. Then aliens could be electronic descendants of once organic creatures that existed long, long ago. Such an idea gives us some exciting possibilities. If AI aliens were out there, they would act and think totally differently from us. Plus, they might not want to be detected. Non-organic intelligence may not need an atmosphere, so they might have already left their home planet. If they didn't need any special conditions, they would be able to make intergalactic voyages without having to fear for their lives. They could prefer to live in zero gravity because, in such conditions, you can build very large and very lightweight structures. For example, if you wanted to construct a giant gossamer-thin structure to harvest energy, it would be easier to do so in space than on a planet. They might not even need to live in orbit around a star. They could have innovative ways of getting energy we can't imagine yet. If their brains were silicon-based, they could realize that they needed less energy to process information at lower temperatures. So, they would move away from planetary systems to colder regions of the cosmos. They could even have periods of hibernation for billions of years. What if they had such a period waiting until the cosmic microwave background, the leftover radiation after the Big Bang, cooled down enough for them to function properly? We can't assume that these aliens would be a civilization either. On Earth, this term means a society of individuals. But aliens might be a single integrated intelligence, or they might be zombies, super intelligent but lacking self-awareness and inner life. In this case, they would be alive but unable to perceive themselves or the world around them. Alternatively, their advanced intelligence might allow them to understand aspects of reality we can't figure out yet. There are likely to be things in the universe that neither our mind nor our senses can grasp. But electronic brains might have a very different perception. Interestingly, these days, humans themselves are starting to use AI to detect alien life out there. After all, there are between 10 and 50 billion potentially habitable worlds in our galaxy alone, and looking for intelligent life is a hard task without some assistance. That's when the US-based research organization, SETI, Search for Extraterrestrial Intelligence, comes into play. This institute is looking for science and technology beyond the solar system. It could be evidence of intelligence out there. But it's a needle in a haystack kind of situation. Luckily, new instruments are helping the search. Artificial intelligence can both handle massive datasets and spot anomalies, which is transforming the hunt for alien intelligence. SETI, together with other research organizations, built an AI-powered software system called the Very Large Array. It consists of 28 large dish antennas spread across a desert plain. When it starts working, the AI will be able to process 2 terabytes of data every second. For comparison, modern laptops typically have around 1 terabyte of total storage. So, hopefully, these new tools will provide us with new, groundbreaking discoveries. We could use one of the largest lasers in the world to detect alien spaceships. If aliens existed and managed to make a spacecraft as huge as Jupiter, our equipment could probably detect it using the ripples its warp drives would produce in space-time. You see, an enormous spaceship is bound to produce gravitational waves while moving around. You can read about a warp drive, also called a drive-enabling space warp, in science fiction. This device distorts the shape of the space-time continuum and is one of several ways of traveling through space. It's often described as similar to hyperspace, a faster-than-light method of interstellar travel. A spaceship equipped with a warp drive can travel at speeds greater than the speed of light by many orders of magnitude. But unlike some other fictitious faster-than-light methods of travel, like a jump drive, it doesn't permit immediate transfers between 2 points. Instead, it involves a measurable passage of time. A spacecraft using a warp drive would still keep interacting with objects in normal space, and produce gravitational waves too. That's why, if any extraterrestrial gigantic spacecraft traveled through our galaxy, the Laser Interferometer, Gravitational Wave Observatory, LIGO, in the US might be able to detect it. Its equipment could search for the ripples in the fabric of spacetime left by the spaceship. The bigger an object is, the larger gravitational waves it would leave. Planets, neutron stars, and even black holes produce quite prominent ripples. For the first time, such space-time ripples were directly detected in 2015. And since then, scientists have been getting better and better at spotting gravitational waves. New calculations published some time ago suggested that LIGO could look beyond conventional sources of space-time ripples. The authors of the study claimed that colossal alien spacecraft traveling at high speeds or pushed along by warp drives could also produce the telltale vibrations. The LIGO detector notices gravitational waves from the tiniest distortions they make in spacetime when passing through it. The observatory consists of 2 intersecting L-shaped detectors, each with 2 arms that are almost 2.5 miles long. They also have 2 identical laser beams inside. The experiment is designed in such a way that if a gradational wave passes through our planet, the laser light in one arm of the detector gets compressed while the other expands. It creates a minuscule change in the relative path lengths of the beams arriving at the detector. At the same time, the warpings of spacetime that even the largest gravitational waves make are barely noticeable. They're often the size of a few thousandths of a proton or neutron. It means that LIGO is incredibly sensitive and requires precise maintenance and calibration. To check how far this sensitivity can stretch, researchers made calculations of the smallest object that would produce clearly detectable gravitational waves on Earth. Apparently, it would still be pretty big. To be detectable by LIGO, an alien spacecraft would need to weigh roughly the same as Jupiter, be within 326,000 light-years away from Earth, and travel at 1/10 the speed of light. Could spaceships of this scale and speed exist? It's unclear, but hopefully, scientists will be able to squeeze down the ship's size to slightly more reasonable proportions thanks to the increasing sensitivity of gravitational wave detectors. For example, in the mid-30s, the European Space Agency's Laser Interferometer space antenna is going to be deployed. Scientists also think that advanced alien warp drives could create a gravitational wave patterns distinguishable from natural sources. If detected, these alien waves could probe at use with answers to how to reverse engineer the technology. All because the shape of the gravitational wave signal is dependent on the trajectory of an object. Once a burst signal is detected, we could attempt to figure out the qualities of the transportation mechanism used there based on the shape of the gravitational wave signal.
People have always been intrigued by the question of how the world could end. Many theories have been suggested, many ideas debunked, and now, in the age of science, rather dire predictions come from physics and math. For example, let's take the theory of the Big Rip. It claims that one day, the pull of the expansion of the universe may grow stronger than the force of gravity. The resulting catastrophe will tear apart everything in space, even terrifying black holes. After that, there will be just clouds of single, disconnected particles floating all over the universe. Before this happens, please subscribe to our channel and like this video. Your support is very important to us. Thank you. And now, let's go into detail about this blood-chilling scenario. The cosmological model of the Big Rip is based on the idea that if the universe keeps accelerating in its expansion, it will one day reach the point where all the forces holding it together will be overcome by dark energy. Now let me explain. Everything on Earth and everything people have ever seen in space, with the help of telescopes and other instruments, is normal matter. It's made up of atoms and molecules and adds up to less than 5% of the universe. Around 68% of the universe is dark energy. Astronomers wouldn't even know the thing existed if, several decades ago, they hadn't found out that the expansion of the universe wasn't slowing down. Quite the opposite. It was accelerating. It meant that there had to be some enigmatic force that counteracted gravity. This force was later called dark energy. You might ask, but what about the remaining 27% of the universe? That's what we call dark matter, and it's another thing that confuses astronomers to no end. If dark energy is a force responsible for the expansion of the universe, invisible dark matter is responsible for the way galaxies are organized on grand scales. It is also supposed to explain how objects work together. Potential candidates for dark matter vary from strange particles to super-dim objects. If one day, the power of dark energy becomes stronger than gravitational, electromagnetic, and weak nuclear forces, the universe is very likely to simply come apart. One of the newest models of the Big Rip theory was published in 2015, and in it, the date when the universe might meet its demise is specified. It's about 22 billion years from now. This hypothesis also says that as the expansion of the universe becomes infinite, its viscosity will decrease. Cosmological viscosity measures how resistant the universe is to expanding and contracting. Eventually, such changes will cause the destruction of the universe. The Big Rip will happen when dark energy overpowers gravity. At one point, it might become so strong that it will start ripping apart atoms. In other words, if the Big Rip theory is correct, one day, the world might come to the point where galaxies, stars, planets, and everything on them will be literally torn apart. This view might turn out to be really spectacular if there was anyone left to marvel at it. Powerful forces will break apart atoms and molecules. Electrons will split from atoms all the way down to quarks, or even smaller pieces we don't know about yet. And then, everything will cease to exist. the Big Rip isn't the only scary theory about what the end of our universe might look like. Another popular hypothesis is the Big Crunch. It says that one day, the growth of the universe will slow down to a crawl, and then gravity will become the main force. It'll make the universe shrink, causing planets, stars, and galaxies to collide with one another. It'll be the Big Bang in reverse, with everything collapsing in on itself. And let's not forget about another creepy scenario, the Big Freeze. The universe is expanding faster and faster. One day, this growth will pull previously visible galaxies too far away, and we won't see them ever again. Many billions of years later, the universe will turn into a huge, dark, empty, and incredibly cold place with no movement at all. There are 8 planets in our solar system, and they're all very different from one another. That's why, if one day they unexpectedly and inexplicably turned into humans, these people wouldn't look alike, and their characters would differ dramatically. Let's try to imagine what humans the planets of the solar system would make. Do you like our videos? Write about it in the comments, and please subscribe to our channel. Let me introduce Mercury. It's a curious and swift teenager around 13. 15 years old. He's always on the move and is a bit hard to pin down. He's into sports and tends not to walk but dash around. That's one of the reasons his knees and elbows are always scratched. He's just like the planet Mercury with all its countless craters. Now, meet Venus. It's a beautiful young lady in her mid-20s. She likes to keep her secrets, and her alluring beauty comes with a temperamental side. At parties, she easily attracts attention because of the mystery surrounding her. But those who dare strike up a conversation with this beauty soon realize that she's scorchingly direct and doesn't tolerate nonsense. Earth is in her late 20s. She is very pretty and extroverted, and has a nurturing, balanced personality, forever the peacemaker, trying to maintain harmony. Earth is the one everyone turns to for advice and comfort. She has a pretty unusual hobby, collecting different life forms, like someone who always brings home stray animals. And if she feels that something or someone is a threat to her beloved pets, she can get furious. Mars is a cool guy in his early 20s. He's ginger and sturdy. He's that ambitious and a bit annoying younger brother, living in Earth's shadow. But he doesn't give up and is determined to make a name for himself. He's a great fan of adventure and exploration, that very type who enjoys camping, wilderness, and slightly dangerous activities. His guilty pleasure is Googling stories about ancient warriors. Jupiter is in his early 50s. He is that protective elder with a bigger-than-life personality. He is a respected head of a large family, known for his wisdom and jovial nature. He also loves to throw big parties that sometimes get out of hand. Saturn, an elegant lady in her late 40s, is stylish and timeless. She is always the best-dressed person at any gathering. She's known for her beauty and has a calm, sophisticated demeanor. She loves accessories, especially elaborate rings. She's got quite a collection. Uranus is in his late 30s, and he has an unconventional, quirky personality. If you have a problem and need a different perspective on something, he's the one to go to. No wonder his planet counterpart has a unique axial tilt. Uranus isn't afraid to be different. He enjoys innovative and boundaries-pushing art, and some suspect he might be a hacker. Neptune is a thoughtful man in his early 40s. He's kind of a dreamer and probably the most creative one in the group. You can often find him lost in thought or swept away by music. He's almost always wearing his large blue headphones. He's very sensitive and has a high emotional intelligence. This quality draws others in. That's not all. Let's look at a space body that used to be a planet, Pluto. It's a very young teenager, quiet and often overlooked. But he has a surprising amount of depth. Despite his introverted nature, he has a group of close-knit friends. It might take time to get to know him, but those who gain his trust discover his different side, endearing and witty. The sun is a big boss. No one knows how old he is because he looks ageless. Rumor has it he frequents beauty clinics, but shh! The sun knows his worth and uniqueness. He's quite caring and nice to his subordinates, but he's also rather hot-tempered and when he gets angry, he expresses his displeasure openly, often by throwing stuff. The moon is a shy 18-year-old girl. It's hard for her to make new friends. She prefers to keep close to the only friend she has, which is Earth. To her, Earth is a motherly figure who can protect and give valuable advice, which also makes her feel rather insecure. But don't worry, Earth is working on her confidence. The main question of all time goes like this: what was there before the Big Bang? The most common theory claims that about 13.7 billion years ago, before this incredible rapid expansion occurred, the universe existed as a singularity. It was a point tinier than a subatomic particle. At least, that's what the Big Bang theory tells us. Okay, but what was before that? This question has been bothering the minds of the greatest cosmologists for at least 1,600 years. For example, 4th century theologian St. Augustine was trying to figure out the answer to the question of what had existed before the universe was created. He made a conclusion that the phrase, "in the beginning," mentioned in the Bible, implied that nothing had existed before that. He also believed that time and the universe had been created simultaneously. The ancient Greeks were also bothered by the same question and kept debating the origin of time. Philosopher and scientist Aristotle, for instance, took the no-beginning side. He thought that nothing could come out of nothing. In other words, to get a universe, you need to have something for this universe to appear from. And since the universe couldn't have gone from nothingness to somethingness, it must have existed forever. That's why time must stretch eternally into the past and future. In the early 20th century, the world got to know about Albert Einstein's theory of general relativity. According to this theory, mass warps time, making it run a bit more slowly for, let's say, a human standing on Earth's surface and a satellite orbiting our planet. Based on Einstein's work, other ideas started to pop up, including the one that stated that the universe started as a singularity and expanded through the Big Bang. Then, quantum physics came into play. It gave birth to a bunch of new theories, which brought forth the questions about the pre-Big Bang universe again. And aren't these ideas fascinating? Some researchers believe that our universe is just an offspring of another much older universe. According to them, the evidence for this theory can be found in the cosmic microwave background, CMB, which is the relic radiation left over from the Big Bang. But let me explain. For the first time, astronomers observed the cosmic microwave background in 1965. At that time, they didn't know it would soon create problems for the Big Bang theory, challenging its ideas and postulates. Now, according to the inflation theory, an extremely rapid expansion of the universe occurred in the very first moments of its existence. This theory accounts for the changes in temperature and density in the CMB. It also claims that these fluctuations should be uniform. But recent mapping results show that the universe is actually lopsided. More fluctuations occur in some areas than in others. This makes some scientists believe that our universe bubbled off a parent universe. There's also a chaotic inflation theory, which takes this concept even further. It believes in an endless progression of bubbles, each eventually becoming a universe. And each of these appearing universes gives birth to even more bubbles, which results in an immeasurable multiverse. There are other models too. Some of them revolve around the pre-Big Bang singularity and black holes. If we think of these space monsters as cosmic trash compactors, they might end up being the main candidates for primordial compression. And our rapidly expanding universe could be a white hole output from a black hole dwelling in another universe. A white hole is a hypothetical object that acts in the opposite way to a black hole. Instead of pulling everything inside, it constantly gives off energy and matter. There's also the Big Bounce theory. Its main idea is that instead of going through one Big Bang, the universe expands and contracts in a cycle, bouncing back every time it shrinks to a certain size. Each cycle, therefore, begins with a tiny, smooth universe that gradually grows, becoming more warped with time. And eventually, it starts to collapse, smoothing itself out before starting anew. If you liked or disliked our video, put a like or dislikes. Leave comments. Let's discuss the mysteries of the universe together. And now don't leave, the video will continue.
In 2017, a strange object was spotted in our solar system. It had the shape of a long tube, similar to a pancake. No known asteroid or comet we've seen looks like that. Its exterior was also peculiar. It was at least 10 times more reflective than the average stuff that flies through space, with some saying it had a surface similar to polished metal. When it went past the sun and left our reach, it accelerated faster than what our gravity could account for. At first glance, it was like this thing had a rocket strapped to its back. This unusual visitor even got a special name, Oumuamua. It comes from Hawaiian and translates to scout or visitor from a faraway land. And because of its characteristics, scientists soon began to wonder if this was at last a visit from otherworldly creatures. Before they went full-on with the science fiction suppositions, astronomers gathered the information they were sure about, starting with the fact that Oumuamua must have come from another solar system. There must have been some unfortunate event in its home system that led to its ejection. What they didn't know was that this was a comet or asteroid. They're both celestial objects orbiting a sun, but they have distinct compositions and behaviors. Comets are composed primarily of ice, dust, and rocky material, often referred to as dirty snowballs. When a comet approaches the sun, the heat causes the ice to vaporize, releasing gas and dust particles into space. This creates a bright glowing tail that can extend for millions of miles. Comets generally have elliptical orbits, often taking them from the distant reaches of our solar system closer to the sun. Asteroids, however, are mostly made of rock and metal. In our neighborhood, they are remnants of the early formation of the solar system and are typically found in the asteroid belt between Mars and Jupiter. Unlike comets, asteroids do not develop tails when they approach the sun, as they have no ice. Their orbits generally follow more circular paths compared to comets. By all accounts, Oumuamua should be a comet, because it seems to come from a different location in the universe. Yet, it doesn't exhibit the typical signs of cometary activity. Oumuamua lacks a tail and does not spew out gas as it passes by, not like me. Even though it behaves like a comet, it looks more like an asteroid. Now, another big question is how scientists even managed to spot Oumuamua in the first place. Considering the vastness of space and time in the galaxy, it's remarkable. Stars have lifetimes spanning millions or billions of years, and the formation of a solar system takes hundreds of millions of years. Even the fastest objects take tens of thousands of years to travel from one star to another. In contrast, humans have only been observing the skies with telescopes for around 400 years, a tiny fraction of cosmic time. And it's only in recent decades, even years, that we've had the technology to detect and track fast-moving, dim objects. Either rocks like these are abundant, or we've been incredibly lucky with our detections, or it's simply wanted to be seen. Now, another question that was asked was where such objects could come from. It's highly unlikely that Oumuamua came from a mature, stable solar system. That's because such systems don't eject enough material to fill up the galaxy. Occasionally, a random rock might get flung out, but it can rarely travel so far. Young systems, however, act differently. In these chaotic environments, collisions, mergers, and migrations are happening everywhere. Plenty of tiny rocks roam around, perfect candidates for ejection. The solar system that kicked Oumuamua out must have had a planet similar to Jupiter. Its massive size and gravity could influence other objects in the system, causing potential ejections. But not all solar systems develop Jupiter-sized planets. Often massive planets end up close to their stars, becoming hotter versions of Jupiter. These planets, snugly orbiting a sun, are less likely to eject debris. Now, Neptune-like planets may play a role too. While not as massive as Jupiter, they tend to call the outer regions of solar systems their home. Our solar system has the Kuiper Belt, a reservoir of comets in its outer reaches. During a solar system's early stages, interactions between Neptune-like planets and debris are common. Finding Neptune-like planets in other systems has been challenging, though. Our methods for detecting exoplanets work better for massive objects close to their stars, making it difficult to spot Neptune counterparts farther out. Oumuamua was also linked to a peculiar theory about how life came to be in the universe – Panspermia. Now that's a hypothesis that suggests that life exists throughout the universe and can be distributed between planets by various means, such as asteroids, comets, or even spacecraft. It says that life must have originated in one location in the universe and then spread to other celestial bodies. Fans of the panspermia theory have suggested that such interstellar objects could potentially carry tiny microbes, those building blocks of life between star systems. If such objects were to impact a planet or a moon, they could transfer these materials and seed the celestial body with life. For now, there is no evidence to support the theory that this comet in particular has transported life between star systems. After years of research, the overall consensus became that Oumuamua was indeed a comet. The reason why it moves so strangely is because it might have frozen hydrogen on its surface that reacts when touched by sunlight. The closer it got to our sun, the faster it became, releasing that hydrogen and also changing its path to our solar system. Its color also supports this theory. It's red, which might mean it's been hit by cosmic rays for a long time. The longer it was touched by those rays, the more hydrogen it gathered in the process. But since they can't be completely sure, astronomers have a plan to follow this visitor. One idea is to send a mission to check it out. It's already far away from us, but it may not be too late just yet. We may be able to send a probe fast enough to catch up with the comet. The plan was named Project Lyra and aims to use the Earth's orbit and that of Jupiter to bounce out a probe far enough to reach Oumuamua. If it works, it will be the fastest space device we've sent out in the universe. One potential trajectory of the space probe involves the gravitational pull of our planet and that of Jupiter as a lasso effect, but not Ted Lasso. The probe will leave our planet and re-enter Earth's orbit before sending it to meet with Jupiter's pull. It will be sent back near our planet a second time, where it will be ejected with enough force to reach the comet. Project Lyra also aims to follow a second faraway visitor named Borisov. This one was discovered by an amateur astronomer and now bears his name. What's interesting about it is that it's, well, spotless. Similar to our experience with Oumuamua, we haven't seen anything like Borisov before either. Studies of the light coming from its cloud of dust and gas show it's very clean compared to other space objects. After it was first noticed in August 2019, astronomers studied its path through our solar system and concluded it came from another star too. But Borisov gave us more time to study it because we spotted it earlier in its journey through our neighborhood. Researchers used advanced telescopes to look at the dust coming off Borisov. They found it's throwing off over 400 pounds of dust every second. They also found Borisov has more carbon monoxide than comets from our solar system usually do. But the amount isn't the same everywhere on the comet. This tells us the space object probably started forming near its home star before moving away, maybe because of larger planets in its system. The light from Borisov is way more polarized than light from other comets we've seen, and its cloud is super smooth. This tells us Borisov has never interacted with another star.
The Fermi paradox essentially queries, why haven't we heard from anyone out there? And why weren't we included in the cosmic conversation? One of the potential explanations for our solitude in the vast expanse of space is the concept of the Great Filter. This idea, introduced in the 1990s by Robin Hanson, postulates a significant barrier or challenge that may prevent life from proliferating across the cosmos. This Great Filter is a metaphorical sieve that civilizations might need to traverse to achieve the kind of advanced state we often fantasize about in sci-fi tales. You've probably seen something like this in the game about Captain Shepard. Regrettably, evidence of such advanced civilizations or even basic extraterrestrial life remains elusive It could be that evolving into higher life forms or mastering interstellar travel is a monumental task. Such an impediment might halt civilizations from progressing, either due to natural cataclysms like asteroid hits and ecological crises, or by their own actions leading to self-destruction. Analyzing this theory, we face two intriguing possibilities. The first suggests we've already navigated past this daunting filter, meaning we've weathered the toughest trials of existence. Yay for us! But this would imply that intelligent life is a rare gem in the vastness of space, leaving us potentially unique and isolated. So our dreams of interstellar friendships and explorations might be just fantasies. On the gloomier side, the second possibility posits that the most challenging tests lie ahead, indicating that while other civilizations might exist, they too face challenges they've yet to overcome. They, like us, might be striving to survive, evolve, and hoping to signal to the cosmos that they're here. Within the discussions of the Great Filter, there's mention of the rise of artificial intelligence, AI. With AI's rapid advancement, it's conceivable that it might turn out to be a double-edged sword for humanity. AI, as highlighted by the Great Filter theory, presents both an opportunity and a challenge. As this technology surges ahead, becoming increasingly integrated into our lives, there's a growing concern about its unforeseen consequences. If not handled responsibly, AI could end up being one of the hurdles civilizations, including ours, struggle to surpass. The potential for AI to reshape our society and even pose existential risks underscores the importance of cautious advancement. Yet, it's crucial to remember that the universe is vast, and the narrative isn't solely one of doom and gloom. There's a silver lining. It's possible that other civilizations, having navigated past their great filters, are thriving in distant corners of the cosmos. Their successes could eventually pave the way for us to communicate, collaborate, or even coexist. Furthermore, life in its most rudimentary form might be closer than we think. Entities not yet sophisticated enough to establish contact might inhabit realms within our reach. Our quest might not always lead us to advanced civilizations. Even the discovery of microbial life would be groundbreaking. Amidst all the speculation and theories, one thing is certain. Our thirst for knowledge remains unquenched. The scientific community remains undeterred in its mission. With every passing day, we probe further into space, and particularly our solar system, hoping to unearth evidence of life. Discoveries, such as water on Mars or conditions suitable for life on some of Jupiter's or Saturn's moons, emphasize that we might not have to venture too far to find hints of life. The universe, with all its vastness and mysteries, continually beckons. We remain eager to uncover its secrets. As we continue our journey through the vast expanse of the universe and its mysteries, your support and curiosity drive us. If you want to stay updated on more such revelations and insights, make sure to subscribe. Together, let's keep exploring the unknown. Don't miss out. Hit that subscribe button now. Time runs like a river. It has direction, always advancing. It has a certain duration, periods between events you can measure. Time feels real, always there, unstoppable, moving forward. But what if I told you that time might not exist? Some physicists and philosophers claim that there might be no such concept as time, and we should take this possibility of the non-existence of time seriously. You see, recently physics has been in crisis. For the past century or so, two extremely successful physical theories have been used to explain the universe. Those are the theory of general relativity and quantum mechanics. Quantum mechanics describes how things work in the super tiny world of particles and their interactions. As for general relativity, it provides an outlook on the bigger picture, for example, gravity or how objects move in space. And even though both of these theories seem to be working really well, they are believed to conflict with one another. That's why some scientists think that they need to be replaced with a new, more general theory, like quantum gravity. This idea might be able to explain how gravity works at the miniature scale of particles. Apparently, it's incredibly difficult to produce the theory of quantum gravity, but it might be possible to do it with the help of string theory. It replaces particles with strings, vibrating in 11 dimensions. But there's one problem. Even though string theories do provide several models describing the universe, they don't make any clear predictions that can be tested by experiments to understand which model is the correct one. There's one more idea known as loop quantum gravity. According to it, the fabric of space and time is made of super tiny chunks, loops. But the most remarkable aspect of this theory is that it completely eliminates the concept of time. Now suppose this idea turns out to be correct. Will it mean that time doesn't exist? Well, the answer is kinda complicated. Everything depends on what the word exist means. A philosophy professor from Cambridge University claims that the three basic properties of time, a present moment that is special, the flow of time, and its direction, come from our mental states and not from the physical world. So we sense this arrow of time because our minds add a certain subjective ingredient to reality. At the same time, Einstein's theory of relativity supports the idea of the block universe, a four-dimensional space-time structure where time is like space. It has its own coordinates in space-time. Time is tenseless there. Thus, the future and past are as real as the present. Does it mean we're being fooled by our human perspectives? Is the feeling that time passes and has a certain direction false? Well, we can imagine our world as a three-dimensional place where stuff happens gradually over time. Or it might be a four-dimensional space where nothing actually happens because nothing changes. It's all here at the same time, past, present, and future. The main idea of relativity is that there's no absolute space and no absolute time. Everything is relative. Trying to think about time in the context of the universe, you realize that you need to isolate part of it and call it, let's say, your watch. And time is basically the relationship between some parts of the universe and that thing you called your watch. Another scientist says that time is just a collection of snapshots describing our reality while continuously changing one into another. Here, you hit play. Here, you're blinking while watching this video. And here, you're taking a sip of your coffee. Without these changes, there wouldn't be any notion of time. The changes are real, but time is not. Our brain sees these changes and constructs a sense of time, believing that it's flowing. What do you think? Is time just a social construct, or does it really exist?
Now, in the 70s, we received a radio signal that lasted more than a minute, and to this day, no one knows what it was or where it was coming from. But now, a new theory has appeared. Could the mystery finally be solved? In 1977, at 11:16 p.m., a telescope in Ohio caught something very unusual in space. It was a super short radio signal, just 72 seconds long. The signal was so strong and weird that the scientist who found it wrote "Wow" in red ink next to it. That's why it's called the WOW signal. Now in space, hydrogen gas sometimes releases radio waves, a type of electromagnetic radiation. They emit at a specific frequency, which is like a unique signature for hydrogen gas. This helps us to find, identify, and study it. Thanks to this, we noticed that the WOW signal frequency came from the same place as this gas. But it's not like it helps much, because we still have no idea what emitted it. What's even stranger, the signal happened only once. Even though we tried really hard to hear it again, we never did. And without a repeat signal, it was impossible to tell what it was. It's hard for us to even get its precise location because the signal was short-lived. After a certain distance, it's very hard to tell where different radio signals are coming from. And that's where the theory started. This particular frequency that the WOW signal was on is special. It's not crowded with a lot of other signals. It's like finding a quiet spot in a noisy room. Because there's not much interference or noise, so if you send a signal on this frequency really far, it won't get lost or distorted. And that's curious, because it means that there might be a perfect place to send messages if we want to communicate with any extraterrestrial creatures out there. So, could it be that they're trying to contact us? Well, it's a real scientific possibility. No one knows for sure what caused the wow signal. But if it was from something extraterrestrial, they definitely communicate not like we do. The signal looked nothing like a deliberate message, and that's weird that it happened only once. If it was little green people trying to contact us, it would be weird for them to only try once. But, just in case, in 2012, on the 35th anniversary of the wow signal, we decided to send out a bunch of messages toward certain stars. We used a special code to make sure any extraterrestrial creatures who got the messages would know they were from intelligent beings like us. Well, mostly intelligent. We even used a lot of power to make sure the messages could travel really far. Scientists have come up with lots of ideas about where the wow signal might have come from, but none of them are widely agreed upon. We know for sure that it didn't come from anything on Earth. Earth noise can interfere sometimes, but this signal definitely came from outer space. There was also a theory that the signal might have bounced off some space junk and come back to Earth, but later we realized that the requirements for that to happen were very unlikely. One potential idea is that the signal might have been caused by twinkling in space, like how stars twinkle in the sky. But even if that's true, it doesn't rule out the possibility that the signal was made by something artificial. Another idea is that it could have come from something spinning, like a lighthouse. Or maybe it was a signal that changed its frequency over time. Or it was just a one-time burst. It's been 50 years since a strange radio signal was caught. But recently, a new idea about its origin sparked up. Now, imagine a comet streaking through space, leaving a trail of gas behind it, like a tail. This gas could be key to understanding the mysterious radio signal that caught astronomers' attention all those years ago. One of the astronomers looked at the wow signal and thought it might be connected to a comet called 266P/Christensen. Yeah, that's a mouthful. This comet is about 1,800 light-years away. It wasn't known back in 1997 when the signal was first detected, but now it could explain the strange radio waves. Comets can emit radio waves as they get closer to the Sun. It's like the gases around them start buzzing with energy. This buzzing might be what the wow signal was all about. To test this theory, we used a radio telescope to listen for radio waves from other comets. We found that some comets did indeed emit radio waves at the same frequency as the wow signal. Then we pointed the telescopes at this particular comet as it passed through the same part of the sky where the wow signal was detected. The comet's radio waves could match up with the signal, and while the comet wasn't exactly in the same spot as the signal, it was close enough to feel like we were onto something here. It also might have been caused by hydrogen clouds from two comets, the ones we mentioned, and another one called P/2008Y2. Who picks these names? But not everyone is convinced by that idea. Some say that the theory about two comets causing the signal doesn't add up, because comets don't usually emit radio waves in the ways needed to explain the wow signal. Also, the signal didn't repeat itself and only happened once, which is weird if it's really a comet. They spread out their gases over a large area, so the signal would have lingered longer. The telescope used to detect the signal should have picked it up twice in a short time span, but it didn't happen that way. Also, the comet wouldn't have moved out of the telescope's view so quickly. This shows that we need to learn more about how and why comets emit these radio waves, especially at the same frequency as the wow signal. There are also a lot of mysterious and interesting signals in space. Most of them come from natural events, like something called fast radio bursts. These bursts of energy are incredibly powerful and occur all over the sky, but their origins are still unclear. They last for only a fraction of a second. Maybe the telescope caught just a part of one of these bursts. There's also a strange signal we've been receiving since 2018. This one actually repeats every 22 minutes, but despite our efforts, we can't figure out where it's coming from. It started way back in 1988, and we've been investigating this mystery for 36 years now. At least here we know the distance of the mysterious object sending the signals, a distant 15,000 light-years away. Some speculate that these signals could be from extraterrestrial beings trying to communicate with us. However, we can't say for sure without solid evidence, so it remains speculative. Another explanation is a pulsar theory. Now, pulsars are neutron stars that emit beams of energy, similar to what we've been observing with the signals. However, the behavior of the signals doesn't perfectly align with what we know about pulsars. There's also the magnetar theory, suggesting that these signals could be coming from supercharged neutron stars called magnetars. Yet, none of these theories fully explain the strange behavior of the signals. Maybe there's a new, undiscovered phenomenon in the universe. So even though comets are a possibility, there are still a lot of unanswered questions about the WOW signal. We don't know what caused it, and we may never know. We don't even know if it came from deep space or from somewhere inside the solar system. In any case, even if the WOW signal had a natural cause, it doesn't mean that extraterrestrial life doesn't exist. The study that talked about this also discussed a sun-like star that could be a great place to look for signs of technology from space. There are 14 more stars similar to our Sun in space, although we're not totally sure about their brightness. This opens up exciting possibilities for hunting down signs of advanced civilizations beyond Earth. Ooh.
Chances are, we're going to find life beyond Earth by 2035, and there's no need to travel to a galaxy far, far away. Our Milky Way galaxy is full of totally suitable environments. Don't get too hyped up though. We're talking about microbes or chemical markers, not Hollywood-like green humanoids. Even so, when we finally find traces of life, it will change how we see our place in the universe. NASA's Kepler Space Telescope discovered something incredible. Almost every star has planets, and many of these planets might be habitable. Rocky planets like Earth and Mars are even more common in our galaxy than gas giants like Saturn and Jupiter. Also, we already know that our galaxy is very rich in water. There's water in interstellar clouds where stars and planets form, in the debris disks around other stars, in comets, just everywhere. What's really hard though is finding life itself. Ideally, to finally find it, we need to land on every single planet out there and literally check under each rock. But thanks to the newest research, we can at least narrow down the search to potentially habitable worlds. The James Webb Space Telescope, a super powerful telescope that was launched into space in 2021, is onto this. It checks the atmospheres of nearby super-Earths, rocky planets that are a bit bigger than Earth. It searches for life-related gases, chemicals that can only be produced by living things. And they already found some clues. For example, they detected signs of such a chemical on a planet called K2-18b. This planet is 120 light-years away, which is pretty close on a space scale. This planet is in the Goldilocks zone, which means a zone around the star where the temperatures are just right for liquid water to exist. It orbits a red dwarf star, the smallest type of star there is. Such stars are a bit fainter than our Sun. It will take about a year to check if these hints of life are real. If so, it would mean that life is much more common than we previously thought. But even if it's not, there are 10 more Goldilocks planets on their list to study. The James Webb Space Telescope is a very cool tool, but it has limits. It can't detect small Earth-like planets due to their size. To fix this, NASA plans to launch another tool, the Wide Field Infrared Survey Telescope. This one will be even better at spotting such planets and life-related chemicals. And also, we have the SETI project. SETI stands for Search for Extraterrestrial Intelligence. This project has been on a hunt for extraterrestrial creatures since the 1980s. They also believe that we'll find signs of life within the next 10 years. Not so long ago, they started a super big and cool project. It's called COSMIC, and it uses an array of radio telescopes in New Mexico. You might have seen those in the movie Contact. COSMIC allows scientists to listen to hundreds of thousands and potentially millions of star systems at the same time. If there are any interesting signals, scientists can check them right away, instead of waiting for weeks or even months. The signals themselves are often very sudden and short, but COSMIC can detect even the shortest ones that last nanoseconds. COSMIC can also help with other research, like studying mysterious and unexplained fast radio bursts, or even dark matter. This is the biggest and most powerful tool for searching for extraterrestrial life we've ever created. But it's not enough to just listen. Why don't we reach out ourselves? NASA has sent some signals into deep space. In 2002, their Deep Space Network sent a signal to the Pioneer 10 satellite. But there was an obstacle in the path: a white dwarf star 27 light-years away from Earth. If there's a planet around this star, perhaps the signal reached them too. If there are any intelligent species there, we could receive a reply by 2029. The DSN keeps sending powerful transmissions into space. These signals will bump into 222 stars within the next 3 centuries. Maybe someday we'll receive a reply from somewhere far away. But why haven't we received a response yet? There are about 200 billion galaxies in the universe, each with around 100 billion stars. If just 1% of those stars had one planet, that's still 200 quintillion possible planets. And we can narrow it down even further. If the chance of them having life is 1 in a trillion, that would still leave us a few 100,000 planets. So, where is everyone? This is a famous question known as the Fermi paradox. The first possibility isn't that terrifying. It's possible that the universe is full of life, but this life isn't intelligent in our traditional sense. Some planets might have microbes, birds, or space dinosaurs. This is called the Great Filter Theory. It suggests that there are certain filters that life has to overcome in order to become intelligent, and maybe other species just haven't overcome them yet. Think about it. Life on Earth started in the ocean, then crawled onto land, diversified into many forms, went extinct in massive events 5 times, evolved again, and eventually led to humans. We built societies, developed healthcare, and only then started searching for another life. There's another idea called the Gaian bottleneck hypothesis, which suggests basically the same thing. While it might not be too hard for basic life to start, it's incredibly tough for that life to survive and thrive over long periods. Venus might have had oceans and Earth-like conditions too, but something went wrong. Its oceans boiled away because of a runaway greenhouse effect. Now it's sterile. Mars also had liquid water on its surface once, and both the Moon and Mercury had thick atmospheres for a short time. Meanwhile, Earth has had liquid water on its surface for almost its entire existence. It's super rare and remarkable for a planet to hold temperatures from 32 to 212 degrees Fahrenheit for millions of years. So, maybe it's a mistake to look for intelligent life, especially the one that uses the same technology as we do. It evolved under completely different conditions after all. That's also where the so-called Drake equation comes in. It's a formula that gives us a chance to calculate the potential of life becoming intelligent on a planet. To calculate the result, we need to know several variables: how many stars there are, how many of them have planets, the chance of these planets having life, and so on. Unfortunately, we don't know these numbers yet, and the result might be insignificant. But let's assume that there is at least one other intelligent species. Why haven't we met yet? There might be many reasons. Maybe they don't think we're interesting enough, or maybe the problem is with us. Perhaps we keep missing their signals, or maybe we miss the entire species itself. The universe is insanely huge and ancient. It's over 14 billion years old. If we compress Earth's entire evolutionary history into a 24-hour day, life starts at 4 a.m. Dinosaurs go extinct at 11:40 p.m. Human-like creatures appear 2 minutes before midnight. In this analogy, humans have existed for just 77 seconds, and our technology capable of detecting extraterrestrial life is even newer, less than a second. With such vast distances and time spans, the chances of us existing at the same time as other civilizations are slim. If their civilization lasted only a few millennia, we could easily miss them entirely. But that doesn't mean we should give up our search. Scientists were worried that Earth's radio signals had dimmed over time. But a recent study showed that it's actually the opposite. The numbers of our satellites keeps growing, and this makes our planet more detectable. By the end of the decade, we could have 100,000 satellites, making Earth incredibly bright in the radio spectrum. If there is an advanced civilization out there, they will easily spot us even from very far distances. Astronomers are super optimistic about it. There's a high chance they'll find extraterrestrial creatures while you and I are still around.
We've been dreaming about life on Mars for a long time. Not only about growing potatoes there in the future, but also about all the potatoes that could have been there in the past. Has there ever been life on Mars? Recently, scientists have found something that could be evidence of that. Let's find out what happened. Mars is the fourth planet from the Sun. A human hasn't set foot on Mars yet, but robots have set their wheels. The first spacecraft that visited the red planet were NASA Viking landers. They flew there back in 1976 and sent us a lot of interesting data. Back then, we didn't know anything about Mars. To us, it looked like a cold, lifeless desert. But since we're so similar, scientists began to wonder, has it always been like this? Or is it possible that once Mars used to be thriving and full of life? And in 2022, NASA's Mars rover Perseverance found something that could shed a light on this mystery. But first of all, what is Perseverance? Scientists have suggested that if there was life on Mars once, it's unlikely that it could simply disappear without a trace. It must have left some traces, perhaps underground, where they would be protected from radioactive solar tantrums and other nastiness. So we need to check the rocks. It's important to note that we aren't looking for life on Mars right now. There most likely isn't any. Instead, we want to look into the distant past of our twin planet. We're talking billions of years ago, when Mars could have been warm, green, and far from lifeless. In other words, we have to find dead microbes and various chemical compounds similar to ones on the Earth. This is the mission of our main character, Perseverance. It arrived on Mars in February of 2021. The spacecraft landed on the bottom of the 30-mile-wide Jezero crater, and after landing, it scooted over to the west, to the place that prompted scientists to choose Jezero for research. This place is a dried-up river delta, and this former river is already more than 3.5 billion years old. The Jezero crater itself was once a large lake. Yup, apparently there was life on Mars, and scientists have suggested that these places would be perfect as bodyguards of microbes. That's exactly what bacteria do on Earth. They hide, being still in the depths of lakes and ponds, so we could probably find traces there. The researchers believe that this particular lake has the highest scientific value in the entire mission. The highest chance to find rocks on which such bacteria could survive is here in Jezero. So Perseverance went to the delta. The row wasn't easy though. The rover missed a little and landed further than planned. As one famous movie said, "This little maneuver's going to cost us 51 years." Fortunately, Perseverance took only 1 year, and on the way, it was able to explore Jezero a little. The rover uses a complex built-in tool to explore the world. The tool is called Scanning Habitable Environments with Raman and Luminescence for Organics and Chemicals, or just SHERLOC. Boy, NASA sure loves its acronyms. As the device approached the delta, the signal of organic molecules became stronger. Soon, these signals were everywhere, and besides, they were the brightest that the scientists have ever seen. What does it mean? Elementary, my dear Watson. You know, Sherlock. It's time to dig! Since July 2021, Perseverance has drilled and collected 4 thin cores of sedimentary rock. The total number of collected rocks at the moment is 12. This is the first time in history that we're collecting something like this on another planet. These 4 cores were found on 2 rocks called Skinner Ridge and Wildcat Ridge. The first pair of cores, the ones from the Skinner Ridge, don't seem very interesting at first glance. They're quite close to what we can find in many places on Earth. However, if we look at them closer, we'll see that they're dotted with round grains of some dark material. These dark grains could have once been deposited on them by an ancient river, the same one that flowed into Jezero. It's possible that the river brought them from places hundreds of miles away from Jezero, and that's pretty cool. If we study these cores, we'll be able to learn even more about the far corners of Mars. Well, there are no corners on it, but you get the idea. Then, in April 2022, Perseverance did arrive at the delta, and then scientists finally found what they were looking for. The discovery, to put it mildly, excited them. They found 2 more cores, which held organic substances. This pair was taken from the Wildcat Ridge. It's found very close to the Skinner Ridge, but the 2 rocks are quite different from each other. These samples are lighter in color and more uniform. Most likely, they're mudstone, an unusual rock similar to clay, but harder and unable to absorb water. They're also finer grained than the cores of the Skinner Ridge. Why does it matter? Because the finer the grains in the stone, the more likely it is that there may be some traces of a past life in it. On Earth, fine-grained stones most often lie on the bottoms of ponds and in similar places. There, they can preserve the remains of dead organisms and similar stuff for years. And this is exactly what we found on them. Additionally, according to scientists, there was more organic matter in these 2 cores than in any other place studied by Perseverance so far. It probably accumulated there while the lake was gradually evaporating billions of years ago. So, there really was life on Mars? Well, let's slow down a little. Organic substances are molecules holding carbon. And yes, on Earth, they're most often associated with life, but not always. Sometimes they can form as a result of other things. Therefore, we cannot say for sure whether there was life on Mars. We don't know if these molecules really remain from some Martian microbes, or if they're the result of some other things. But the discovery is still very significant. We have to literally keep digging this way. To learn more about this organic matter, scientists need to collect a couple more samples of fine-grained rock. It would also be great to study the material lying around these former reservoirs. Perseverance has already moved to another area, to a place with a beautiful name, Enchanted Lake. Now it needs to look for similar things there. It will also continue to study Lake Jezero. Eventually, Perseverance will climb to the top of the delta and then continue exploring ancient sites outside the crater. Sometime before the end of 2022, Perseverance will probably have 6 or more samples of the Martian cores. Unfortunately, its tools, though complex, are quite limited. This data alone won't be enough for us to get a complete picture. Therefore, NASA plans to send other spacecraft to Jezero in the coming years. Together with the European Space Agency, they're working on the next robotic mission, known as the Mars Sample Return. The name speaks for itself. These devices will arrive and take away all the test tubes from the old Prospector Perseverance. After that, these samples will be delivered to Earth, though not by Amazon Prime, and then scientists will be able to analyze them in advanced laboratories. However, all this will take a really long time. The launch of this mission is scheduled for 2027-2028, and the spacecrafts won't be able to return until 2033. But if everything goes well, it will be the first samples in history delivered to Earth from Mars. In other words, there's still enough space for research, literally. And yes, we don't yet know the true meaning of these finds. But that's why the entire mission was created, right? And who knows? Maybe in a few years we'll finally find out the truth about what happened on Mars billions of years ago. Ooh, check out The Martian! Made you look. Consider now
Enceladus,
Saturn's icy moon, one of the most promising places to look for life outside Earth. Scientists have just detected the last one of the 6 necessary ingredients for its formation, phosphorus. This rarest element has been discovered in an ocean on Enceladus. This rare element helps make the soil fertile on Earth. But the concentration of this mineral in the hidden seas on the distant moon might be from 100 to 1,000 times greater than in the oceans of our home planet. It might be because
Enceladus,
ocean is rich in carbonates, just like soda water, and this soda water is likely to dissolve the phosphates in the moon's rocks. The new discovery also suggests that on other icy moons of Saturn, like Titan, the waters may be loaded with phosphorus too. Why are scientists so excited about this mineral? Well, phosphates, which are compounds that contain phosphorus, are crucial components of life on Earth. DNA, RNA, and cell membranes contain them. But among those 6 elements required for life, which are carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, phosphorus is the least common. In 2004, the Cassini space probe entered the dust from the second outermost ring of Saturn, called the E-ring. It's made up of ice grains in Enceladus ejects. And while studying these ice grains examined by Cassini's cosmic dust analyzer, researchers have detected phosphorus.
Enceladus
Is the 6th largest moon of Saturn. It's not really large, only 314 miles across. This makes the space body small enough to fit inside Arizona. We should try that sometime. Interestingly, when the Cassini space probe first arrived at Saturn, astronomers thought that
Enceladus
was going to be a frozen ball of ice. But then, surprise, surprise, they spotted plumes of icy particles and water vapor erupting from geysers on the moon's surface. It became clear that there was a global ocean between the moon's rocky core and its icy shell. The same researchers previously discovered that Saturn's moon might be home to complex organic molecules, too. Before, scientists thought phosphates could be trapped within the rocky cores of
Enceladus
and similar worlds. That's why the newest works, which hint that phosphates might also be abundant in the ocean, came as a surprise. Researchers examined 305 ice grains from Saturn's E-ring and found out that 9 of them contain phosphates. And these results were clear and unmistakable. And it's very important because some time ago, phosphine, a compound of hydrogen and phosphorus, was believed to exist in the clouds of Venus. But no one has managed to find any evidence to support this theory. On
Enceladus
there's no controversy, and phosphates do exist there. Astronomers consider Europa one of the most promising places in the solar system to search for new life forms. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick, but it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. Of course, it's going to be challenging for any life-seeking mission to access such a deep environment. On the bright side, as we are, scientists already have some evidence that there are way shallower pools that probably lie much closer to the surface of the moon. They might be located even less than 1 mile under the ice. And there are 2 great things about this news. First of all, it boosts the odds of life existing on Europa. And secondly, if it's true, it can make it easier for future missions to find these life forms, if there are any. Then we've got Titan, Saturn's largest moon. It's smaller and has lighter gravity than Earth, but it still reminds us of our planet. Like on Earth, nitrogen dominates its atmosphere. Titan is the only other world in our solar system with lakes and rivers. These water bodies are made of hydrocarbons, methane, and ethane. There's also a subsurface ocean of water, but it's located very deep down, and no one has figured out yet if this ocean makes contact with anything under the surface. If it does, it could provide fuel for life after mixing with complex chemistry on the surface. But
Enceladus
and the other icy moons aren't the only place in the solar system that might host or once hosted life. In 2003, Mars Express, A spacecraft launched by the European Space Agency discovered methane in the atmosphere of Mars. On our planet, the biggest part of this gas in the atmosphere is produced by living creatures, for example, by cattle digesting food and emitting, gas. However, scientists think that methane was stable in the Martian atmosphere for about 300 years. And then, in 2006, the methane almost entirely vanished from the red planet. And it happened 600 times faster than the researchers' model accounted for. The question? What or who generated the gas, and where did it go? Another Martian mystery is microbes that might be sleeping beneath the surface of Mars. There, they might have been protected from the harsh radiation coming from space for millions of years. Scientists simulated the conditions on Mars in a lab to check if it could possibly be true. And they were amazed to find out that bacteria could easily survive in such conditions for 280 million years. Ooh, that's a long shelf life. This means that if life existed on Mars, we could find the evidence in the planet's subsurface by drilling into the Martian soil. Right now, there is no flowing water on Mars, and cells or spores would simply dry out. Plus, the frozen temperature is similar to that of dry ice. In other words, it's deeply frozen. Let it go. And still, there could be 6 types of bacteria and fungi living underground on the red planet. The most likely of them is nicknamed Conan the Bacterium due to its tough nature. Well, I guess time will show. Anyway, if we don't find life outside Earth in our solar system, we could probably look for it on exoplanets, which is what planets outside our star system are called. Some of them look very promising. The closest to Earth exoplanet is Proxima Centauri b. It's a mere 4.2 light-years away from Earth. Recently, astronomers have found out that this world might resemble Earth even more than they previously thought. It's just 17% more massive than our home planet. It orbits a star that is dimmer and less massive than the Sun. Proxima Centauri b is in the middle of the star's habitable zone. This means that the chances of liquid water and life might exist on the planet. It looks like the exoplanet is tidally locked with its parent star. One of its sides faces the star at all times, and the other is always in the darkness. Scientists haven't figured out yet whether the planet has an atmosphere, is traveling too close to its star, and completes one orbit within 11 Earth days. The radiation from the star might be pulling the planet's air away. If this is the case, Proxima Centauri b isn't likely to have liquid water on its surface. Gliese 832c is 16.2 light-years away from Earth. In the cosmic scheme of things, it's a stone's throw away. This exoplanet is 5 times as massive as Earth and travels much closer to its parent star. That's why a year on this planet lasts a mere 36 days. But since this star is a red dwarf, much cooler and dimmer than the Sun, Gliese 832c gets as much light and heat as our planet. At the same time, it's still unclear if it's similar to Earth. The planet probably has a much thicker atmosphere that creates a runaway greenhouse effect. This phenomenon occurs when a planet absorbs more heat from its host star than it can release back into space. This means that Gliese 832c is more likely to resemble scorching hot Venus rather than the relatively cool Earth. Hey, I'm cool with that. Okay, here you are in the middle of the ocean. It's endless, but you can't see it because there's a thick fog all around you. Dense clouds hide the huge but dim sun. Is it day or night? You don't know. There's only a gray haze around you. You're alone. Even if you try to swim down, after several hours, you still won't be able to see the bottom of the ocean. And that's a typical water planet for you. I know, sounded kind of dark, but it's not that bad. These water worlds are more interesting than they may seem, so let's take a look at them. The ocean planet is a planet that consists, as you might have guessed, mainly of water, ice, and maybe some rocks. Think of the Earth's oceans. Its horrifying depths, the Mariana Trench, and all that. And now, can you guess how much space all the water on Earth takes up? 0.025%. Exactly. Now, just try to imagine a world of 40 to 60% water. If you dive in there, the depth can exceed 60 miles. Compared to that, the 6-mile depth of our Mariana Trench sounds like nothing. And yeah, the pressure there will be enormous. It can reach up to 20,000 Earth atmospheres. Very crushing. Now, it may sound scary, but it still would be great to find out more about these planets. Fortunately, according to scientists' calculations, there may be a lot of such planets in our galaxy alone. Well, you don't have to go far. You can find these water guys even in our solar system. Not planets, of course, but moons. Jupiter has Ganymede and Callisto, and Saturn has Titan and Enceladus. The ocean can reach up to 30% of the mass of these moons, although it isn't clear whether these oceans are covered with a thick crust of ice. But we've discovered quite a few full-fledged ocean planets. This is because the conditions in which these planets may exist are very specific. For example, this planet should be somewhere 6 to 8 times larger than the Earth. If it's smaller, it'll have a rocky surface, but if it's bigger, it'll turn into a gas giant. At the same time, it must be in the habitable zone of its star. A little further, and the planet immediately turns into an icy giant or a cold super-Earth. So yeah, these guys are very picky. We first started exploring these planets back in the 1970s. However, since then, we've found only a couple of them, but they're still very interesting. The first planet is Gliese 1214b. It was the very first ocean planet that we discovered. Initially, the scientists noticed only a small dim dot. This dot turned out to be the red dwarf star Gliese 1214, an unremarkable, completely ordinary star that's 5 times smaller than our Sun and 300 times dimmer. Scientists wouldn't worry about it at all, but back in 2009, they noticed that this star had one single planet, and this planet turned out to be quite strange. This super-Earth was 2.5 times bigger than our Earth and 6.5 times heavier, but at the same time, it had a very, very small density and about the same gravity as our planet. In other words, there were almost no rocks and metals on it, but it wasn't a gas giant either. So there was only one option left. It was covered in water and ice. And that's how we discovered the first ocean planet. Well, actually, we can only assume that it consists of water. That's what the mathematical calculations say. In reality, this planet is quite confusing. It's difficult to explore, and so far, scientists haven't been able to find anything there. No hydrogen, no helium, no water, nada. That's because the outer layer of the atmosphere of this planet is very dense, and it perfectly hides its composition. But even so, it's probably a water world. Gliese 1214b is very close to its star. It's only 0.014 astronomical units away, which is less than the distance between the Moon and us. The year there lasts about 36 hours, and the temperatures, to put it mildly, are just wild. Scientists suggest that the average temperature there can reach 250 to 535 degrees Fahrenheit. Woo, that's hot. Remember the creepy description from the beginning? Well, actually, spending time on Gliese 1214b would be a little different, more like swimming in a steam boiler. Because of such gigantic temperatures, the ocean on the surface will be constantly in a state close to boiling without actually reaching it. So, imagine that you're descending to the surface of this planet, flying through clouds of steam, and then you suddenly find yourself in the water. What? But when did it happen? Well, that's because the boundary between steam and water on Gliese 1214b will be very blurred. Of course, you won't be able to swim to the bottom of this ocean, but most likely, this bottom is covered with a very thick layer of so-called hot ice. It's like regular ice, but it doesn't really care about the laws of physics, so it just doesn't melt even at gigantic temperatures. And the thickness of this ice can reach as much as 3,000 miles. So that's it for the creepy Gliese 1214b, and not an Airbnb in sight. Now, although we can't 100% guarantee that it's a water world, we still have another candidate for this position. A newly discovered planet called TOI 1452b. This planet, located in the Dragon constellation, is almost 100 light-years away from us. It was discovered using the TESS telescope by a group of researchers from the University of Montreal. This planet also belongs to the class of super-Earths. It's 7 times larger than our planet, but 48 times heavier. Again, all this is at a very low density. Because of this, scientists have suggested that almost the entire planet consists of a giant ocean. Here, we were a little luckier. This world won't be just a giant puddle and some thick ice. On this planet, there's probably a rocky surface deep under the water, just like in a typical ocean. Don't get too excited though. This ocean will certainly be very different from what we're used to. TOI 1452b also orbits a small red dwarf. And not even one, but two at once. At the same time, if the previous planet was close to its sun, then this one, on the contrary, is very, very far away. It's 2.5 times farther from its stars than Pluto is from the sun. And it moves at great speed. A year there lasts only 11 days. But we still don't know many things about this planet. We'll probably get some new information when scientists observe it from the James Webb Telescope. Well, that's it. Wait, did you expect something else? All right, I know the question that bothers you the most. Can there be life? Well, this is a difficult question. We all know that water means life, and besides, these planets are in the habitable zones of their stars. So, potentially, yes, there might be life. Not some full-fledged civilizations, of course, but bacteria, fish, and some creepy giant monsters. I mean, why not? However, this is very unlikely. Water alone isn't enough to create life, even though it's very important. There should also be some microelements and some minerals. And unfortunately, for most water planets, the composition will only consist of water and very thick ice. There won't be any minerals there. But don't give up. There's still some probability. First of all, there are meteorites and comets. They can bring the necessary minerals to the planet. The more often they crash into it, the higher the probability that they'll bring something like this into the ocean and thus create life. Secondly, TOI 1452b actually has these minerals. Yes, we don't know how deep the rocky bottom is located there. But if it exists, then surely something could have originated there. Let's hope that new research with powerful telescopes will allow us to find out the truth. And who knows? Maybe one day we'll be able to visit such a planet ourselves. TRES-2b, or not to be, is a planet where night never ends. And it's not your regular night with stars shining in the beautiful skies. Here it's pitch dark and scorching hot. TRES-2b is a gas giant, roughly 1.5 times more massive than Jupiter, and its surface absorbs light better than charcoal. It might also have a faint dark red glow because of its burning air, which is as hot as fresh lava. Lovely. In the star system of 55 Cancri, there are 5 planets, 4 of which are gas giants similar to Jupiter and Saturn. But the 5th one, or rather the first because it's closest to the star, is different in a most horrible way. 55 Cancri e is so close to its sun that half the planet's surface is a literal ocean of molten lava. The other half is in eternal darkness because it never sees the sun. The planet is always turned to its star on one side. And between the scorching and the dark, there's the twilight zone, a thin strip of gloomy nothingness. That's a getaway spot. HD 189377b, well, I'm not going to say that again, is the only exoplanet in the orbit of its star. And at first glance, it looks quite pretty, blue and white swirls making up wondrous patterns on the surface. But these pleasant colors actually come from hard silicate particles in the planet's atmosphere, which means it rains glass here. But the worst is that winds reach the speed of 5,400 miles per hour, or almost Mach 7. Well, for comparison, the fastest wind speed on Earth was 254 miles per hour, over 20 times less. Thus, the glass falling from the sky travels horizontally at hypersonic speeds, shredding everything in its path. Better duck. The next system, whose name I won't even try to pronounce, this one, has 3 exoplanets, which are all being slowly destroyed by their own star. It happens because that star is not irregular. It's a pulsar, a rapidly spinning core of an exploded star. It creates powerful electromagnetic pulses in several directions while rotating at several thousand times per second. As a result, the planets orbiting this deceased star are slowly being eaten away and will eventually disappear entirely. Kepler 70, hey, I can say that one, is a hot blue dwarf star that exploded into a red giant some 18 million years ago. At the time, it was orbited by at least 2 planets, the closer of which was a Jupiter-like gas giant. Its name was Kepler 70b, and it still exists, but the overgrown star consumed it and transformed it into a blazing hot rocky world. Right now, it's one of the hottest planets ever discovered. Its temperature is higher than the surface of our Sun. It was lucky to survive spending time inside the star, but it's evaporating now and will probably be no more in the near future. WASP 12b is one of the weirdest and saddest planets out there. The enormous gravity of its star, combined with the planets consisting mostly of gas, result in the star slowly devouring its protege. So pal, what's eating you? My mother. WASP 12b has already taken the form of an egg, stretched toward its merciless sun, and it's unable to do anything with its condition. In another 10 million years, the planet will inevitably succumb to the voracious star's appetite. Hey, you asked. If you ever wondered what it's like to walk on ice and hot coals at the same time, Gliese 436b is a planet that would give you a vivid example. Being extremely close to its sun, the Neptune-sized exoplanet boasts temperatures hotter than a blazing oven, and yet it's covered in ice, which burns incessantly. This ice is much denser due to the enormous gravity of the planet, staying solid even under extreme conditions and not melting away. No list of frightening worlds could do without mentioning Venus, the Earth's evil twin. The second planet from the Sun has an atmosphere so thick and full of clouds that its surface is much hotter than that of Mercury. Volcanic eruptions constantly thrash Venus. Its gravity is almost 100 times stronger than ours, and those clouds I mentioned are not made of water but of sulfuric acid, which condenses and rains down on the ground, adding to the inferno. But even if you were brave, or crazy, enough to try to pass through these clouds, you probably couldn't. The winds up there are as strong as some of the most powerful hurricanes back on Earth. Here we have a very long name for a very, very cold planet. Although the host star is not too far away, it's a small and rather cool red dwarf, whose light and heat barely even reach the planet. The temperatures out there fall as low as minus 370 degrees, which is only marginally warmer than absolute zero. The exoplanet is thus dark, gloomy, and covered in eternal ice that never thaws. I thought I thaw that somewhere. Still, if it has a rocky core, it might generate some heat, so there's a chance that deep below the frozen surface, some unknown alien things might lurk. Dimidium, located roughly 50 light-years away from our solar system, is a planet hostile to any living thing on many accounts. It's tidally locked to its sun, which means one of its sides is always facing the star, while the other is always turned away. The hot side is heated to over 1,800 degrees, perpetually blown over with winds reaching 600 miles per hour. And that's winter. Well, actually, I don't know that. Despite Dimidium being a gas giant, it has a large amount of iron in it, which melts and evaporates in the atmosphere, creating clouds. And when those cool down, they fall on the surface in the infernal rain of molten iron. That'll test your mettle. Oxygen is usually viewed as an element that might bring life to a planet, but this is definitely not the case for Osiris. Scientists were shocked to find oxygen on this planet, or rather around it, because it's 8 times closer to its star than Mercury is to the Sun. This extreme distance makes Osiris a living melting pot, where anything that could burn will. It's also responsible for a very short orbit of the planet around the star. A year on Osiris is just 3.5 days on Earth. To boot, the atmosphere of the planet is constantly blown and melted away by the heat from its sun. Vacation? Nah, let's keep looking. Karat Exo 3b is neither as hot nor as cold as some of the others on this list, but it's terrifying in its own more insidious way. It's a gas giant similar in size to Jupiter, yet 20 times denser. This makes this exoplanet's gravity weigh down on everything on its surface 50 times more than it would on Earth. Stepping on it would be your ultimate doom, because you'd be immediately crushed by the density of its atmosphere. Karat 7b is another oven-like world. Its day-to-day temperature is over 4,000 degrees. Combined with the rocky surface, it presents an infernal landscape. The rocks on the ground bubble and boil, evaporating in the atmosphere, where they cool down and eventually fall back on the surface in a brimstone rain. The saddest thing about Karat 7b is that it might have once been a gas giant whose atmosphere melted away from the heat, leaving only the scorched core.
Look up when the sky is clear at night. You'll see thousands of tiny bright dots there. It may seem like they're fixed in one spot, but in reality, they're constantly moving. In 100,000 years, there won't be a constellation with the same shape or pattern we know today. And think about all those red dwarfs, small stars, planets, space bodies we can't see with the unaided eye. Red dwarf stars are especially cool. They're usually about half the size of our sun, and mostly 1/10 as bright. They may not be the brightest things in the sky, but they live for a very, very long time. Nuclear fusion reactions happen deep in star cores. That's what makes them shine. Large stars release huge amounts of energy, burning their stellar fuel. But such stars tend to burn all their fuel in only a couple of million years. Stars like our sun usually live for about 10 billion years, but red dwarfs don't use that much of their fuel. Their light is not so powerful, and they don't require much energy to support their existence. They're like energy-efficient cars. That's why they can last hundreds of billions of years. Some of the smallest ones may live for up to 10 trillion years. Most hydrogen in sun-like stars remains unspent. There's more of this gas in the atmosphere rather than in the core of such stars. This means most hydrogen doesn't take part in the fusion reactions. But it's different with red dwarfs. They circulate plasma throughout their entire bodies. These stars pull fresh hydrogen reserves from their outer layers into their core. That's what keeps fusion reactions running. One day, in the distant future, stars like our sun will run out of fuel and shut down. The universe will be full of small red dwarfs. They won't have enough energy to shine and brighten the space around them. Our descendants, if there are any, will inherit a dim, dark cosmos. As it gets older, the sun will balloon to a size where it will destroy nearby planets. First Mercury, then Venus, and then us. On the other hand, Earth will probably survive, but barely and not for long. The sun will burn it to a crisp when it gets closer. The outer planets of our solar system will also survive, but they'll move even farther away into space. The sun will lose some of its mass while increasing in size. Its gravitational pull establishes the orbits of the planets. When our star becomes less massive, the pull of its gravity will become weaker, and the outer planets won't have such a strong connection with the sun. Our solar system is not isolated. There are many other stars in our galaxy. Within 30 billion years, stars that travel nearby will mess with our outer planets, enough to rapidly launch some of the biggest ones out of the solar system altogether. The last planet to stay will stick around for a while longer, maybe even 100 billion years. But even that one will eventually end up kicked out of the solar system. There's a theory claiming that we got most of the water on our planet from ice-laden meteorites and comets, frozen balls of ice and dust. As they crashed into the early Earth, they probably brought water, which was necessary to develop life. But those very same objects that might have created life on our planet could also be its end. This is not a matter of if, more a matter of when. And scientists think it's very likely that an asteroid or comet big enough to wipe out life on Earth will smash into our planet. But it'll happen in the distant future. And fortunately, we have the technology to predict such things and react on time. But there are other cosmic collisions we can't avoid, no matter what we do. Andromeda, our neighboring galaxy, is moving toward the solar system at a speed of 68 miles per second. There are 2.5 million light years between the Milky Way and Andromeda, so luckily our neighbor won't cover that distance anytime soon. It'll only happen in around 4 billion years. Such a collision of two galaxies might lead to real chaos for our descendants, if any of them are still living on Earth, that is. The two galaxies will slide past each other. Then they'll draw apart until the gravitational force starts pulling them back together. As they merge, they'll both lose their disk-like structure and form one big elliptical galaxy. It's already got the nickname Milkomeda. The Milky Way as we know it today won't exist anymore. Space is in constant motion, changing all the time. Scientists have a couple of possible scenarios of what might happen with the universe in the future. Number 1, the Big Rip. This theory claims that the universe will expand infinitely. At one point, the pull of the expansion will get stronger than the gravitational force keeping it all together. If this happens, it will tear apart galaxies, stars, black holes, and all other space bodies, including Earth. The universe will turn into a bunch of disconnected particles. Until about 5 billion years ago, the universe was expanding slowly because of its powerful gravitational pull. Then its growth sped up. Some experts say it happened because of the effects of dark energy. Dark energy is a mysterious force that makes up almost 70% of our universe. This force pushes it to expand faster rather than slowing it down. So, in the case of the Big Rip scenario, dark energy will win over gravity to the point where it will be able to rip apart individual atoms. Scenario number 2, the Big Crunch. There's a possibility the universe will get to the point where it'll stop expanding. Gravity will become a dominant force. It might even reverse the expansion of the universe. Then, the cosmos will start shrinking, making planets, stars, and even entire galaxies collide. In the end, the whole universe will collapse in on itself. Once everything compresses into one infinitely small point, which is something called the Big Crunch, the universe may start expanding once again. Theory number 3, the Big Freeze. Brrr. In this scenario, entropy will grow until it reaches its maximum value. Entropy is basically the idea that everything in the universe declines into disorder at some point. Once entropy gets to its maximum, the heat in the system will be spread evenly. The universe will then disappear because there won't be any room for heat to exist. Any mechanical motion inside the universe will stop. The cosmos will be so empty and gas will be so thin that no new stars will be able to form or shine again. In such a cosmos, time is just an endless void. Nothing ever happens with planets, stars, or living beings. The entire universe is frozen, dark, and motionless because there's no energy that can make things start working again. Many, many billions of years after the last stars burn out and fade, black holes will send a message that the universe has come to an end. Black holes are areas with extremely strong gravitational pull, so powerful that nothing can escape it. They can be as massive as 100 suns. As for supermassive black holes, their mass can be greater than that of 1 billion suns. You can find such giant black holes at the center of most galaxies. Like everything else, black holes will experience the same end. But when their moment comes, they won't gently disappear into the night. Black holes will go away in enormous bursts of fireworks, lighting up the universe in the last moments of their existence. It will be the end of the entire era. Black holes usually survive by gobbling down the stars and gas that come close enough. Their gluttony is the main feature that gives them away. In most cases, there's an accretion disk around a black hole. That disk is made of all those materials and particles it's torn apart and is pulling inside, similar to when water swirls down a drain. As the materials and particles draw closer, they start to move faster and faster. This generates heat, which makes the accretion disk glow, which again gives away the black hole. Yep, black holes aren't that great at hide and seek. Things that cross a black hole's event horizon, which is also called the point of no return, are lost forever. But Stephen Hawking had a theory that you might be able to escape from a black hole. There are particles moving even in a vacuum. Let's say one particle has positive and one has negative energy. If they both come close to a black hole, there's a chance that one will fall into it while the other will escape. That means the black hole has radiated the particle away. And this particle has taken some of the black hole's mass with it, which is why the black hole may start shrinking. As it begins to evaporate, it loses its mass and slowly becomes smaller. More and more particles start leaving until all the energy that's left behind escapes all at once. In the final tenth of a second, there will be a giant flash of energy and light in a very, very small region of space. And then, it's all gone. 13.8 billion years ago, a mysterious explosion happened in space. It was chaos, a time when the stars, planets, asteroids, the rest of the space bodies, and galaxies were born. It was the Big Bang, a theory we all know about. But no one knows for sure what happened, where the universe came from, and what was there before. Some even think the universe went through a cycle where it contracted and expanded several times. In 1991, a cosmologist from Stanford University named Andre Linde had submitted an article with the main idea that there was a possibility the universe had been created in a laboratory. His theory said there was a chance an advanced civilization somewhere out there had created our universe. This civilization has made an entirely new cosmos that later evolved its own planets, stars, and intelligent forms of life. 30 years later, many scientists take this theory pretty seriously. They even started talking about things that we, as a civilization, can do to get to such an advanced level. The theory says this advanced civilization decided to add technology that helped to create a new universe out of nothing. It happened through quantum tunneling. It's when an atom can appear on the opposite side of some barrier, even though it's supposed to be impossible, considering the laws of physics of our world. Like if you wanted to pass a tall wall, but you can't pass it with ladders or go around somewhere. Imagine you can just walk through it like a ghost. In our world, it's not possible, but a more advanced civilization perhaps can do it. Plus, they realized how they could create new universes. Right now, on the cosmic scale, we could be a Class C civilization. We don't know how to recreate some things. For example, conditions on the Earth for when our central star, the Sun, goes out. If we manage to become a Class B civilization, we'll learn to adjust conditions to be independent of the Sun. That means we might be able to learn how to live even without it. And if we level up and become Class A, we'll know how to recreate cosmic conditions and produce our own cosmos in our laboratories. We think of the world we live in through 3 dimensions of space: east-west, north-south, and up-down. There's also 1 dimension of time, which means we can distinguish past from future. A 5th dimension would represent 1 more extra dimension of space. The theory of its existence was first mentioned in the 1920s. It was inspired by the theory of gravity by Albert Einstein, who said space-time is warped by matter and energy. We can't perceive these 4 dimensions, but we see how an object moves and attribute it to gravity. And maybe there's some other force, like the electromagnetic force, that's more than 1,000 times stronger than gravity, that could explain things going on in that extra dimension of space. The 5th dimension is curved in a way we can't see it, but the idea about it was mentioned in a string theory. It considers the universe as really small strings of mass energy, not as particles. They vibrate in 10-dimensional space-time, considering 6 dimensions are rolled up way smaller than a single atom. That led to the picture of the universe as a 3D island that floats in 10-dimensional space-time. Also, the 5th dimension might be an excellent explanation to tell us more about dark matter. That's the invisible stuff with a mass, but we can't see it, nor can it interact with ordinary matter. And dark matter is 85% of all the matter in our universe. The universe can't be still. It's constantly in motion, either contracting or expanding. We used to think there were 100 billion galaxies, but it turns out there are more than 1 trillion. The galaxies are moving away from each other. This is what it means when scientists say the universe is expanding all the time. There are voids between galaxies that sometimes stretch millions and millions of light years across. They can seem empty, but they can also contain way more matter than we can find in galaxies. Still, stars usually can't be formed there because the matter between those areas has lower density. But there's still plenty of so-called intergalactic stars. A good example is the Virgo galaxy cluster, 10% of which are intergalactic stars. We don't know how exactly they got there, but there are 2 possible ways. 1. Stars can collide, merge, or pass close to another galaxy, which can kick it off from its parent galaxy. Option number 2. A supermassive black hole can accelerate a star to very high velocities if they have a close encounter. which can, again, make a star be expelled from its parent galaxy. If you could have a giant magnet, you could even pull something out from the vicinity of a black hole. That's possible if the magnetic field near a supermassive black hole is as strong as the black hole's gravitational field. But it doesn't work if we're talking about material that's already beyond the black hole's event horizon. That's a spot with a gravitational force so powerful, not even light can get away. You'd need to accelerate this material to the speed of light, at least, to get away. For that, you'd need an infinite amount of energy. But a magnet could help if something's heading toward the black hole but didn't get inside yet. When someone mentions a black hole, you might get a picture of some giant void in space. But the Milky Way is most likely full of thousands of smaller black holes that float around the galaxy. When a star comes to its end, it will destroy itself in a supernova explosion, which is a cataclysm of energy. In that explosion, the densities in the core will reach an intense enough state that nothing will be able to escape. At the same time, the major part of the star explodes outward, but a part of it collapses inward, creating a black hole. The bigger the star, the bigger the hole. The black hole then swallows everything that comes in its way, including other stars as well. When a star gets sucked up into the black hole, it's ripped apart because of the strong gravity inside the black hole. Some of its parts fall into the black hole, while others get ejected at incredibly high speeds. Some black holes might have been formed in a different way. The early stages of our universe were, to say the least, pretty chaotic. It had high temperatures and pressures, and was in a state that shaped the entire cosmos. Under the right conditions, any old gas patch may have shrunk itself to become a black hole. And they came in many different sizes, from something that weighs a couple of pounds to giant masses like thousands of suns, and those in between. They aren't really black. Black holes are areas with strong gravity, and no object can escape when it gets inside. They feed off electromagnetic radiation, such as light and space particles. Since they're consuming matter all the time, black holes give off a dark glow. The Earth is not that close to the inhospitable edge of the solar system. We're the sixth planet from it. Scientists made a pretty cool 3D map of our solar system where we can see what the edge looks like. It took them 13 years to design it. The boundary is called the outer heliosphere. It marks the area in space where the solar wind, which is the stream of charged particles our sun emits, gets deflected and draped back by the radiation coming from the empty region beyond our solar system. The inner layer of the heliosphere is where the sun and the planets have a rough shape of a sphere, while the outer layer is not that symmetrical. This asymmetry happens because our sun is moving through the galaxy and goes through friction with the radiation in front of it.
NASA made this cool rover called Curiosity and sent it to Mars to see what else we can find out about the red planet, the one that will possibly become our next home. Curiosity has been exploring the surface of Mars, taking measurements and gathering data about the planet for more than 10 years. And good old Curiosity stumbled upon some interesting wave-rippled rocks in the region of the Martian surface that was kind of expected to be drier. Scientists believe this area was actually a lake bed. It might be the bottom of a dried-up lake and all that sediment and other things that have accumulated there. All this can give us some important clues about the history of the lake. For instance, the types of organisms that might have lived there, how deep the lake was, how long it was there, and similar stuff. These wave-rippled patterns tell us that these rocks may have formed when strong Martian winds were moving the water in this big ancient lake. You know that specific sound you can hear when you're holding a seashell to your ear? You actually hear it because of the way the air gets trapped inside the shell and moves against its walls. The air cannot escape, so it vibrates at frequencies that depend on the size of the shell. In other words, you have a feeling you hear the sound of waves hitting a shore. That's Mars in my imagination now, a spot where you can still hear the long-lost sound of waves crashing against the shores of mysterious gigantic lakes. During its mission, Curiosity also came across a metallic object which turned out to be a meteorite. This unusual rock that came from space is made of nickel and iron. Its name is Cacao, and it's about the size of a small car, 6.5 feet long, and weighs over a ton. This is an important discovery because we don't often find metallic objects on the Martian surface. Most of the rocks there are made of basalt or some other volcanic materials, so that chunk of metal could tell us more about the history of Mars and how it formed. Plus, it definitely stands out. The surface of Mars is red from oxides, while Cacao is metallic-looking and dark gray. It's rounded and smooth, too, which means it once passed through Mars's atmosphere. There have been other robots exploring Mars, too. For instance, NASA's Mars Reconnaissance Orbiter, MRO, stumbled upon circular sand dunes. Sand dunes are usually very common on the red planet. They come in many different shapes and sizes, but circular ones like these are really rare. They consist of dark sand with light-colored material surrounding them. And the cool thing is that these dunes are arranged in a specific pattern, similar to the spokes of a wheel. It could be because of the way the winds blow. But back to our buddy, Curiosity. It's been exploring many other interesting things, like oxygen levels in the Martian atmosphere. The levels change depending on the season. There's more oxygen in the spring and summer. It's still not clear why, though, and of course, even that is not enough for us to really breathe there. The concentration of oxygen on Mars is 0.1%, which is about 100 times less than the concentration in Earth's atmosphere. The atmosphere of Mars is mostly made up of carbon dioxide, with traces of other gases. Curiosity was so good that it also decided to analyze the age of rocks it found. It seems they're much older than we previously thought. Some of them date back more than 3 billion years. Curiosity found organic molecules in soil samples too. These molecules are basically building blocks of life. Now, this doesn't prove there's indeed life on Mars. It's just one of the things that suggests there might have been some form of life a long time ago. Curiosity discovered potential evidence that there might be a large reservoir of liquid water beneath the south polar ice cap, probably very salty and full of different minerals. This high salinity is the reason why this water could remain liquid at temperatures well below freezing. It would be cool to have some sort of subsurface ocean to take a dip in, especially when these crazy Martian winds are raging on the surface. And it would be great to have something that would protect us from those insane radiation levels on the red planet. There are some pretty toxic chemicals and salts in the Martian soil, which can be really bad for humans. Astronauts could potentially end up being exposed to these toxic chemicals, either through direct contact with the soil or by inhaling dust that contains these salts. Also, these substances could be a problem for growing crops. This is a really big discovery for long-term missions to Mars, because astronauts would need to be able to grow their own food so they can survive while there. Another thing that favors the idea of potential life on Mars is discovering methane there. Methane is a very important finding because usually living organisms produce this gas. So, where did it come from if not from them? In reality, there are a few possible explanations for that. One is the geological activity of underground reservoirs. Another idea is that meteorites brought methane to the red planet. What's interesting is that levels of methane are higher in particular areas. So, yeah, I don't know about you, but I'll stick to the theory that it comes from living organisms. Now, it's possible that volcanoes on Mars are still active. We know there are many extinct volcanoes on the red planet, but we've never found enough evidence to prove that some of them are still alive. Scientists studied volcanic deposits and found out that some volcanoes could have erupted maybe 50,000 years ago. Before that, everyone thought the last eruption happened 3 to 4 billion years ago. If you could compress the geological history of Mars into just one day, this would be like having an eruption a second ago. So, you never know. There might still be magma bubbling in secret under the Martian surface. All the future generations that might end up building their life there could really have some fun. Mars turned into a cold and barren place that can't really support life over time, and one of the main reasons for that was losing its atmosphere. The red planet used to have a much thicker atmosphere, similar to Earth's. One major reason for that is its relatively weak magnetic field. Earth's magnetic field helps protect our atmosphere from the solar wind, a stream of charged particles that comes from the Sun. Without this protection, Mars had nothing to help it confront this insanely strong force that eventually took away most of its atmosphere. Another factor that played a big role in the loss of Mars's atmosphere is its relatively low gravity. Because Mars has weaker gravity than Earth, it's easier for gas molecules to escape into space. So Mars probably used to be more similar to our home planet. But with its current thin atmosphere, it can't keep any heat, which makes it very cold and very complicated for us to explore. But maybe it's better for us that we didn't visit the red planet back in its old times. There's this story about an ancient megaflood that might have happened there. So yes, the red planet probably used to be a wetter and more hospitable place than it is today, with beautiful flowing rivers and amazing lakes, ponds, and other bodies of water. And some research showed evidence of large channels carved into the planet's surface. These channels are way bigger than any we previously found on the planet. They suggest this megaflood happened billions of years ago. Perhaps it happened as a result of different factors, like volcanic activity, melting ice, and the release of carbon dioxide from the planet's crust. The flood may have created some temporary pools of water, too. Hopefully, it will mean more interesting clues for finding traces of microbial life. How about that?
In May 2024, stunning auroras adorning the night sky demonstrated all the power that solar storms emit as radiation. But sometimes, our sun does things that are far more destructive. I'm talking about solar particle events. During these events, blasts of protons coming directly from the surface of the sun can shoot out like giant cosmic searchlights. According to records, an extreme particle event hits Earth every 1,000 years or so. It often causes bad damage to the ozone layer and increases levels of ultraviolet radiation closer to the surface of our planet. Luckily, Earth's magnetic field acts as a powerful protective cocoon for our planet, fending off electrically charged radiation from the sun. In its normal state, this field functions like a ginormous bar magnet, with field lines rising from one pole, looping around the planet, and dropping at the other pole. This pattern is sometimes called an inverted grapefruit. This vertical orientation of the magnetic field at the poles allows some ionizing cosmic radiation to get through the field as far down as the upper atmosphere. There, it interacts with gas molecules and produces the glow we know as auroras. But over time, Earth's protective bubble changes. In the past century, the North Magnetic Pole moved across northern Canada at a speed of about 25 miles per year. Plus, it weakened by more than 6%. Even more shockingly, according to geological records, there have been periods of time as long as centuries and millennia when our planet's magnetic field was super weak or entirely absent. But we'll talk about those tragic times later. It's easy to imagine what our planet would look like without its protective bubble if you look at Mars. The red planet lost its global magnetic field long ago. And once this field disappeared, most of Mars's atmosphere vanished too. In May 2024, a strong solar particle event hit the planet. It disrupted the operation of the Mars Odyssey spacecraft and made radiation levels at the surface of the red planet rise around 30 times higher than what a person receives during a chest X-ray. The sun's outer atmosphere constantly emits a changing stream of electrons and protons, the solar wind. At the same time, the surface of the star also produces bursts of energy, mostly protons, during solar particle events. These bursts of energy have a connection to solar flares, extremely powerful bursts of electromagnetic radiation that can last from minutes to hours. Protons are way heavier than electrons and carry more energy. That's why they can reach lower levels of Earth's atmosphere, exciting gas molecules in the air. These excited molecules emit X-rays invisible to the unaided eye. Dozens and hundreds of relatively weak solar particle events happen during every solar cycle. Now, let's speak about solar cycles for a minute. You see, from a distance, the sun seems to be calm and steady, but if you zoom in, you'll see that its surface is constantly seething and churning. It keeps transforming from a uniform ocean of fire to a chaos of warped plasma and back again in a repeating cycle. Every 11 years or so, the magnetic field of our star gets tangled up. Imagine a ball of tightly wound rubber bands. That's what it looks like at such moments. And then, at one point, it snaps and flips completely, turning the North Pole into the South Pole, and vice versa. Right before this event, the sun steps up its activity. It starts to spit out giant blobs of fiery plasma, emit powerful streams of radiation, and grow planet-sized spots. This period has the name of solar maximum. It's a rather dangerous time for Earth, since it gets regularly hit by solar storms. Such storms have the potential to disrupt communications and damage power infrastructure. Even worse, solar storms can harm astronauts working in space and even make satellites crash into the planet. As the cycle ends, it fades back to the solar minimum, and then a new cycle begins. Anyway, back to our solar particle events. Researchers have found traces of extremely strong solar events happening throughout the history of Earth. And some of them were thousands of times stronger than anything our modern instruments have ever recorded. Such extreme solar particle events happen approximately every few millennia. The most recent one occurred around 993 CE. Beyond the immediate effect they have, solar particle events can kickstart a chain of chemical reactions in the upper atmosphere. And these processes often lead to depletion of ozone, which isn't a good thing. Ozone absorbs harmful solar UV radiation, which can damage not only our eyesight, but also the DNA of living beings. Plus, changing the amounts of ozone in the atmosphere can impact the climate. In a recent study, researchers used large computer models to examine how extreme solar particle events affect Earth. They found out that if a solar proton event arrives during a period of time when our planet's magnetic field is very weak, then ozone damage can last for 6 years, and the level of UV radiation might increase by 25%, boosting solar-induced DNA damage by around 50%. And apparently, this dramatic combination of a weak magnetic field and extreme solar proton events happens quite often. And some researchers believe that it may even explain a few mysterious occurrences in the past of our planet. For example, the most recent period of weak magnetic field started 42,000 years ago and lasted for around 1,000 years. This period included a temporary switch in the North and South Poles. Several major evolutionary events happened during that time. For example, the last Neanderthals disappeared in Europe, along with the extinction of marsupial megafauna in Australia. Yeah, sadly, we won't see any giant wombats and giant kangaroos anymore. One more, even bigger evolutionary event might also be linked to Earth's geomagnetic field. Multicellular animals appeared at the end of the Ediacaran period, which started around 635 million years ago, and it occurred after a 26 million year period of extremely weak or even absent magnetic field. The rapid evolution of different groups of animals in the Cambrian explosion, about 539 million years ago, might have also been related to high UV levels and geomagnetism. The simultaneous evolution of hard body shells and eyes in multiple unrelated groups could have been necessary to detect and avoid harmful incoming UV rays. A complete reversal of Earth's geomagnetic poles might have a serious impact on the climate of our planet. Luckily, such flips don't happen overnight. The entire process stretches over thousands of years. Plus, even though the magnetic pole weakens during a pole reversal, it doesn't disappear completely. That's why the magnetosphere continues protecting the planet from cosmic rays and charged solar particles, even though there might be some amount of particulate radiation that will make it to Earth's surface. Our planet's magnetic fields are generated by moving electric charges. If some material allows these charges to easily move in it, it's called a conductor. Metal is a great conductor, and we often use it to transfer electric currents from one place to another. In this case, the electric current's negative charge, called electrons, move through the metal. The current is what generates a magnetic field. Earth's outer core is made of liquid iron and nickel. In other words, there are layers and layers of conducting material inside our planet. Currents of charges are constantly moving throughout the core, and the liquid metal is also moving and circulating there, generating the magnetic field. This magnetic field, in turn, produces something resembling a bubble around the planet. It's called the magnetosphere, and it's located above the uppermost part of the atmosphere. This layer shields and deflects high-energy cosmic ray radiation, which otherwise would be extremely hazardous to people and other forms of life on Earth. The magnetosphere also interacts with the ionosphere, the layer of our planet's atmosphere containing loads of ions and free electrons and capable of reflecting radio waves. The interaction between these two layers and magnetized solar winds is what scientists call space weather. The solar wind is normally mild, and there's no space weather whatsoever.
You're one of over 8 billion people alive on Earth. Let's zoom out. Our planet is just one of 8 planets in our solar system. In the galaxy, our neighborhood is just one of almost 4,000. And from what we know so far, there are billions of galaxies in the entire universe. That itself may also be growing. It's highly unlikely that we're the only living creatures in the universe. Surely, there must be some other habitable planet. Here's where the Fermi paradox comes in. The idea got its name from a man named Enrico Fermi. Back in the 50s, he pointed out that if other life forms were out there and had the tech to travel through space, they should have visited us by now. These days, we have better telescopes that allow scientists to discover over 5,000 planets outside our solar system. Yet, still no sign of life. Throughout the years, there have been many suggested solutions to the Fermi paradox. These outer world beings may be just too far away for a friendly chat. We've seen it in movies, spaceships traveling between stars as easily as cars on a highway. But in reality, making a way through space is a slow and cumbersome process. Even our fastest rocket would take thousands of years to reach a nearby star. When you add in the vastness of the cosmos, it's like trying to find a living needle in the biggest cosmic haystack available. Now, we could just as easily be the very first civilization to emerge in the universe. It's a lonely thought, and it also puts a lot of pressure on us. If we're the only ones, we need to preserve life on our planet, not just for our sake, but also because if we fade away, all life fades away with us. The universe has been around for billions of years, but intelligent life like ours has only existed for a tiny fraction of that time. Maybe we're just early bloomers, waiting for someone else to catch up. To support this theory, a study was done in 2015 using the Hubble Space Telescope. And this is what it showed. Out of all the worlds that could sustain life, only 8% are as old as the Earth. The rest of them are too young and still haven't reached that point in their evolution for life to thrive. There could also be the possibility that our galactic relatives are watching us from afar. A scientist from another planet may be studying us as primitive life forms right now. He may not want to disturb us just yet, the same way we look at ants in an ant farm during science class. On that same note, maybe they're just not ready to interact with us because they've calculated a precise, perfect timing for our meetup. So they're lying dormant in a hibernation status. And they might be right to do so. Why rush into things when we've got all of eternity ahead? There's also the idea that our planet and us humans just aren't cool enough for others to play with, and won't be until we're evolved enough to be welcomed into the Galactic High School's senior class. Or perhaps life is more fragile than we believe. A 2016 study suggested that it's in the early years of a planet where life makes its way. That's when the planet is cool enough for water to form. But those conditions may not last long thanks to the greenhouse effect. So even if life has existed in the universe every now and then, it never evolved to a stage where it could have contacted us. And what if life's ultimate test comes much later? Several thinkers believe that civilizations tend to destroy themselves at some point in their technological evolution. And this may be a potential future for us, too. We're just not there yet. Maybe we'll come to build technology so smart and so powerful that it will overwhelm us, leading to our demise. Well, if it can happen to us, who's to say it didn't happen to other species in the past, on other planets? Amidst all these theories, there's one possibility that's both sobering and profound. We may truly be alone in the universe, forever. Perhaps the conditions for life are so rare that Earth is the only oasis in a vast desert of emptiness. The creepiest answer to the Fermi paradox has a name, though, and it's called the dark forest theory. It first appeared in the 1980s. According to it, the universe is a huge version of a haunted forest, and other types of creatures are out there playing a game of hide-and-seek. It's the expanded version of the survival of the fittest. History on Earth shows that less technologically advanced groups usually end up worse off when meeting more advanced ones. The huge differences in technology often lead to a situation where attacking first seems like the best option. If there's even a small chance that cosmic neighbors might harm us, destroying them first could be our only hope. So if the galaxy is full of advanced life, it's smart for us to stay quiet and avoid contact. Other civilizations would probably reach the same conclusion. Even peaceful ones might feel forced to attack to survive. That's why some scientists criticize the idea of sending messages out there and think searching for them might be pointless. But this idea isn't new. A story from the 40s called First Contact describes humans meeting other types of civilizations for the first time. The two groups became friends, but can't risk letting each other find their home planets. They'd rather destroy each other than risk their safety. Another story, The Forge of God, talks about the danger of our signals reaching hostile species. It compares Earth's broadcasts to a baby's cries attracting wolves. It suggests that we might be in danger because of our naivete. The dark force theory was also explored in a radio play called Calls from Far Away. It shows how discovering otherworldly life on Pluto changes people's views. Some claim the news is fake, others try to understand the reality that we're not alone. But it also suggests that maybe we should focus on our own problems instead of reaching for the stars. If that doesn't sound scary, this will. We've been sending signals of our existence into the cosmos for decades now. By now, any potential civilization within 100 light-years of us might be getting our signals. And if they're advanced enough, they'll know exactly where to find us. If there's any reason why we need to hide from them, it's already too late. Galactic cousins aside, we do need to continue our research for habitable planets for a more pressing reason. Our cozy Earth won't be here forever. When our star fades, all life within the solar system will fade with it. Current estimations claim we've got about 1.3 billion years left before our planet becomes uninhabitable. It will become too hot for water to exist, and without water there is no life, at least not as we know it. So, it begs the following questions. What if there are other types of creatures out there that don't need water to exist? Our type of life needs water because it acts as a solvent. It's an environment where various chemicals can interact with each other to generate something that lives. Some new piece of research suggests that there may be a substitute for water out there in the universe – carbon dioxide. At certain temperatures and under a certain amount of pressure, it acts the same way, allowing chemicals to mingle. If that's true, then our list of known habitable planets would increase dramatically. Sure, we humans will probably never be able to survive on their surface, but other creatures may have evolved to do so. One planet that may feature these weird life conditions is closer than we think – Venus. Its atmosphere is made out of 97% carbon dioxide. It's also very hot and has enough pressure to sustain this theoretical model.
Imagine a world of seething hot metal where iron and nickel dance in a fiery inferno. This is the inner core, the heart of our planet. But what if this very heart was changing? The latest research suggests that the Earth's inner core may be slowing down and even reversing its rotation. Is this a sign of the end of times? Will the Earth come crashing down on itself? Let's find out. Imagine you have a giant onion, and every layer represents a different layer of the Earth. The center of this onion, the part you can never reach, represents Earth's core. It's like a mysterious land that no one has ever set foot on, yet scientists have been trying to uncover its secrets for centuries. Imagine diving deep into the center of the Earth, beyond the crust, the mantle, and finally 1,800 miles below the surface where you'd reach the inner core. It's a ball of seething hot metal made up of solid iron and nickel, and it's so hot it glows a brilliant white. It's also surrounded by a liquid outer core. This mysterious place is unlike anything else on our planet. And get this, it's spinning on its own axis. The inner core is like a fire tornado that's constantly swirling, generating heat and energy from the inside out. But why is it so important to study this little piece of the Earth? Well, it's responsible for creating our magnetic field. This magnetic field is important to study because it protects us from harmful radiation from the sun. It's created by the movement of molten metal in the Earth's outer core and the spinning of the Earth. These movements generate electrical currents, which then create the magnetic field. It's like a shield that protects us and helps us keep our planet healthy and safe. But there's still so much we don't know about the inner core. For example, how did it form? Scientists believe it started to solidify about 1 billion years ago. But why did this happen? What was the trigger? Or, for example, what about the inner core's crystal structure? It's thought to be a type of iron called hexagonal close-packed iron, but we still don't know if it's actually the case. In other words, we may have many theories, but unfortunately, there's no way to confirm them, at least for now. So how do scientists study the inner core if no one can go there? They use seismology. Seismology is like a sonic scanner for the Earth. You send sound waves through the Earth and measure how they bounce back to see what's inside. That's basically how we discovered the inner core way back in the 1930s. Imagine you're listening to the sound waves with your special seismology machine. Suddenly, you hear a strange sound like a ping. It's different from the other sounds you've been hearing, and you can't explain why. You keep listening and you hear the ping again and again. You start to realize that this ping is happening every time the sound wave hits the Earth's center. You study the data more and more, and finally, you figure it out. The Earth has a solid core. This discovery was a big breakthrough and helped us better understand what's inside our planet and how it works. Right now, scientists also use something like this to study what's inside our planet. When earthquakes occur, waves travel through the Earth and bounce off different layers, including the inner core. By studying these waves, scientists can learn about the inner core's properties, such as its density and temperature. They're basically solving a mystery by piecing together tiny clues. And every new discovery brings us one step closer to understanding it. The inner core is a unique and fascinating part of our planet. It's a place where the laws of physics work in different ways than they do on the surface. And it's a place where scientists are still trying to unravel its many mysteries. And here's one of them. For some reason, the heart of our planet is about to stop spinning. A new study about this was published in Nature Geoscience. It was made by the researchers at Peking University in China. It has revealed a huge twist. The scientists found that the inner core spin rate has slowed down significantly. It's something that no one expected, but according to the results of their study, the slowing down began all the way back in 2009. And that's not all. Their results also suggest that the inner core may be reversing its rotation. That's right. This hot ball of iron and nickel that has been spinning around for millions of years may be slowing down and changing direction. It's like when a spinning top starts to slow down, except this is happening in the center of our planet. Scientists have been puzzled over the discovery for quite some time now. So, what does it all mean? And why is this happening? Well, it turns out that there might be a larger pattern at play. The scientists believe that this change in the inner core's rotation may be due to the influence of Earth's mantle and the magnetic field of Earth's outer core. The mantle and the outer core are affecting the inner core, which is causing its spinning rate to slow down and potentially change direction. Before this study, scientists thought that the inner core was spinning faster than the Earth's crust. However, this new information suggests that the inner core may be slowing down due to the gravitational effect of the Earth's mantle and the magnetic field of its outer core. But here's where it gets even more interesting. When researchers took a closer look at data stretching all the way back to the 1960s, they discovered that the rotation of Earth's inner core was consistent from the late 1970s to the early 2000s. Before that, they found that another possible slowing down or reversal event may have occurred in the early 1970s. It's like the inner core spin is like a roller coaster ride, speeding up, slowing down, and possibly reversing course over a period of time. The researchers estimate that these switches occur every 7 decades or so, which is pretty wild. But why is it happening? Unfortunately, we still have no idea. The exact reasons for why the Earth's inner core sometimes stops and starts spinning in another direction aren't yet well understood. However, scientists believe that it may be due to complex interactions between the solid inner core and the surrounding molten outer core. A lot of different things can be at play here. The changes in the temperature, pressure, and composition of the core, as well as the movement of material within the core itself, and so on. Also, as we said before, the Earth's magnetic field and the gravitational forces from the surrounding mantle might also play a role here. We need further research to fully understand the mechanisms behind the inner core's rotation changes. So, is the world ending? Fortunately, no, not just yet. While the inner core is changing direction right now, it's not the end of the world as we know it. And even though findings may seem like a huge deal, life on Earth's surface hasn't been impacted much, if at all. In fact, it's just a fascinating part of the Earth's inner workings that we're learning more about every day. So, you can say with relief, nothing cataclysmic is happening. Moreover, according to Hrvoje Kalsic, a geophysicist at Australian National University, the inner core is now more in sync with the rest of the planet than a decade ago when it was spinning a bit faster. All in all, this new study has added a strange twist to the story of Earth's inner core, and scientists believe that there's still much more to discover about this mysterious place. Who knows what other secrets lie in the heart of our planet? The possibilities are endless. So let's keep researching and enjoy our time on this amazing planet. They aren't supposed to exist. No one expected to find them. Scientists can't explain how they formed. And still, the James Webb Space Telescope has found them. These 6 galaxies, as massive as our home Milky Way, are full of mature red stars. They're so far away from us that they look like tiny reddish dots, even to this extremely powerful telescope. Astronomers have analyzed the light coming from these galaxies and estimated their age. They appeared 500 to 700 million years after the Big Bang. So far, nothing surprising. Galaxies that young aren't exactly rare. Scientists think that our first star clusters could have sprung up soon after the universe left the so-called Dark Ages. Those were the first 400 million years of its existence. At that time, only a thick fog of hydrogen atoms filled the cosmos. What is extremely bizarre about these galaxies is their tremendous size and the age of the stars inhabiting them. But this doesn't coincide with the existing ideas about what the universe looked like and how it evolved in its early years. Plus, it doesn't match with earlier observations made by the Hubble Space Telescope, Wabe's less powerful predecessor. So, according to scientists, what are early galaxies supposed to look like? The answer is simple: young and small. And indeed, previously, most early universe galaxies we found were just space babies, blue and small. They seem to have appeared out of the primordial cosmic soup just recently, and were still building their early stars and other structures. Most young stars are actually blue. As they age, they acquire a reddish glow after burning through their star fuel and cooling down. That's why astronomers were not ready to see old red stars in those ancient galaxies Webb telescope was built to discover. Another thing they weren't ready to spot was galaxies more massive than 1 billion suns, and still, it happened. The most massive galaxies discovered recently seem to have masses just twice or 4 times lower than that of the Milky Way. And the most astounding thing here is that these galaxies were already that big when the universe was a mere 3% of its current age. But before astronomers start rewriting their theories, trying to explain how such huge galaxies formed so fast after the Big Bang, we need to make sure that what we're looking at isn't some other space phenomenon. Even so, most alternative theories need totally new concepts as well. One of them goes like this. Perhaps stars in the early universe emit light in some unusual, exotic way. And since astronomers didn't know about it, they didn't include this possibility in their models. Or our understanding of how stars form might be inapplicable to the early universe. If any of these theories turns out to be true, it'll overturn our understanding of star formation altogether. Now, how about we talk about the device that helped astronomers to discover those bizarre galaxies? The James Webb Space Telescope is an absolutely stunning piece of equipment, which is around 100 times more powerful than the Hubble Space Telescope. And the latter has observed places that are 13.4 billion light-years away. The James Webb Telescope is also on the pricey side, to put it mildly. Even though originally, the cost of the telescope was estimated to be just 1 to 3.5 billion. The whole development process cost around $10 billion. For comparison, it cost NASA $4.7 billion to build and launch the Hubble telescope. It was another $1.1 billion to fix it in orbit. Even though the James Webb Space Telescope itself is 3 stories high and the size of a tennis court, its mirrors are the lightest large telescope mirrors of all time. During the manufacturing process, they underwent a 92% reduction in weight. When you look at them, the telescope's mirrors seem to be gold, but in reality, they're made of beryllium. This is a steel gray, lightweight, and brittle metal. A gold coating is applied to each mirror, that's true, but they can't be produced entirely out of gold, since this precious metal tends to expand and contract, even with small temperature changes. So, the total amount of gold in the James Webb Space Telescope is less than 2 ounces. That's a golf ball-sized piece of gold. And the gold plates covering the mirror are only 1,000 atoms thick. As for the telescope's abilities, it would be able to clearly see a US penny from 24 miles away and a football from 340 miles away. James Webb's telescope side is cooling itself down, and its temperature doesn't rise higher than negative 370 degrees Fahrenheit. That's cool enough to make liquid nitrogen. A truly enormous 5-layered sun shield surrounds the telescope and reflects away as much sunlight as possible, letting the telescope stay cool. JWST is believed to be able to detect water on distant exoplanets. For a long time, astronomers have been discovering planets orbiting stars outside of the solar system by monitoring slight dips in stars' light. Such dips happen when planets pass in front of them. Plus, it's possible to read unique signatures in the light. This can tell us about a planet's chemical composition. And the strongest and most readable signatures happen within the infrared spectrum. And guess what? James Webb has state-of-the-art infrared instruments. They can help scientists spot new planets and even identify the presence of water there. The telescope was launched near the equator because Earth spins a bit faster there, and this gave the rocket some extra push. When the James Webb Space Telescope runs out of fuel, it'll keep orbiting the Sun indefinitely. On the other hand, even though the telescope wasn't actually designed to be serviced or upgraded, it might potentially be refueled with the help of robots. This would extend its lifespan. Interestingly, at first, astronomers were sure that finding something exciting with the help of James Webb would take time. They thought that the first discovered galaxies would be so small and dim that the telescope would only find some remote candidates at best. But it didn't go as planned. As soon as the first images were released, scientists started finding countless galaxies, bright, large, and impressively old. The competition is still on. One research group after another spots new record-breaking worlds. One astronomer even said that the scientific world was freaking out since no one had actually expected such impressive results. One of the main goals of the Webb telescope is to observe the light from the very first stars and galaxies in the universe. Unfortunately, the farther away an object is, the faster it's moving away from us. And the longer the light has to travel, the more it stretches towards the infrared side of the spectrum. This is called redshifting in astronomy. But thanks to its infrared equipment, James Webb can reveal previously invisible worlds to us. So, thanks to this telescope, we've managed to see incredibly distant galaxies that were born around 3.8 billion years ago. It means that the light JWST detected took more than 13 billion years to reach Earth. Can you imagine that? But one of these galaxies stands out from the rest. It appears to be the oldest galaxy astronomers have discovered so far. It's called Glass Z13, and it dates back to a mere 300 million years after the Big Bang. The previous oldest galaxy scientists identified was found by the Hubble Space Telescope, and it dates back to 400 million years after the Big Bang. During that scarcely probed era, the very first galaxies and stars started to appear. But how exactly did this process unfold? No one knows for sure, yet. It might have depended on the laws of some exotic physics, including the influence of dark matter and dark energy, or some poorly investigated communication between gas, dust, and starlight. With the help of the Webb telescope, scientists can now test their theories about what was happening out there after the birth of the universe. About a third of all grown-ups have a snake phobia, but if you decide to become an astronaut not to have to deal with them, it might not be a great idea. According to Story Musgrave, there are snakes in space. Musgrave is one of the most experienced astronauts in the world right now. He is the second astronaut who managed to go on 6 space flights and fly on all the space shuttles. With that much experience and time in space, he has to have 1 or 2 space horror stories in his career. Once on a space mission, he looked out of the window and saw something resembling a snake. Musgrave said it was 6 to 8 feet long and looked like a snake. But many people don't believe his story. They claim it was some trash floating in space or something that had detached from the spacecraft. But the astronaut went on another mission and saw the creature again. The first time he spotted it, it could be some detached piece from the spacecraft. But what are the chances of that happening twice? He gave many interviews in which he explained these crazy encounters. Let's hope those snakes stay in space and don't come crashing down on Earth. If they are real, of course. Snake rain would not be fun. As we all know, Space is like a giant vacuum chamber with zero air, and sound can't travel there, making this story even more terrifying. To communicate, astronauts have a special system in their suits to exchange information. Young Li Wei shared his terrifying experience, and it's hard to believe it actually happened. You would be terrified if you were alone at home and someone started knocking on your door at night. Of course, if you weren't expecting anyone. Imagine the same scenario, but you're in space. You hear some knocking, you have nowhere to run, you're trapped in a metal can floating into nothingness. Young was sitting in his spacecraft, minding his own business, when he suddenly heard knocking coming from outside. How is it possible? Sound can't travel in space. The noise was unique. The astronaut described it as if someone had been knocking on an iron bucket with a wooden hammer. Li Wei looked outside, but to his surprise, there was nothing there. He investigated a bit more, but couldn't find the source of the sound. When Young returned to Earth, he was eager to tell scientists about what had happened, but he could not recreate the sound. To add fuel to the fire, his colleagues, who were on the same mission from 2005 to 2008, said they had also heard knocking similar to what Young had reported. This is still a mystery. Nobody knows what happened then. Maybe it was just spacecraft noise, like those your house randomly makes. We've already mentioned that sound can't travel in space, but that doesn't stop weird noises. The Apollo 10 mission was one of the most significant space missions ever. So, astronauts had to ensure everything was perfect before they went on a moon exploration journey. 3 people were on that mission: Thomas Stafford, module pilot John Young, and lunar module pilot Eugene Cernan. They had to do tons of gear tests for the upcoming Apollo 11 missions. The astronauts were circling the moon when they heard music coming from somewhere. It wasn't like Ed Sheeran's concert, it was more like constant loud screaming. Then, it was quiet whistling. They were terrified. Imagine being in space for the first time and hearing weird noises. The sounds lasted for a whole hour. The astronauts had never heard anything like that before. The sound was otherworldly and creepy. When they returned to Earth, they didn't know if they should tell someone about their experience because it was hard to believe. Michael Collins, an astronaut from the Apollo 11 mission, later shared that he had also heard this sound. But there is a kind of logical explanation for this. Engineers from NASA said that the sound that they had heard had been caused by the interference with the communication system. So you can relax and throw your tinfoil hat in the trash. But before you do that, Al Worden, an astronaut from the Apollo 15 mission, said that this explanation was unlikely, so we might never find out what really caused the sound. Leroy Chiao was the commander of the International Space Station in 2005. When it comes to space, he's seen a lot of things that can send chills down your spine. One encounter he and his crew had will live on in their head rent-free forever. Chow was sitting in the space station doing his job when he suddenly spotted light from the corner of his eye. He took a closer look, and it resembled an upside-down V, floating and glowing in space. Leroy later explained that he hadn't been scared by the object. Quite the opposite. He was extremely excited to see it, even though he had no idea what it was. His crew also saw the strange object. Chow was convinced he was visited by something not from Earth. His team could also vouch that indeed they saw something unexplainable. The information about this encounter is all over the internet, and many people are skeptical. It could have been anything. There are more than 10,000 satellites in space right now. It could have been a satellite floating in space. Another theory is that those were lights reflecting from a fishing boat on Earth. But who knows? There may be another logical explanation for this phenomenon waiting to be discovered. Horror stories don't stop there. This one is hard to believe, and it's up to you to figure out if it's true. Astronaut Alan Bean was the fourth individual to set foot on the moon's surface. When he was on the Apollo 12 mission, he claimed he saw a unique shape on the moon. It was shiny and shaped like a shoe. It's hard to know what he saw because he passed away in 2018. Chinese lunar rover Yutu 2 also discovered some shiny substance on the moon. Scientists say it was something gel-like. It could be a glaze that formed when something impacted the moon's surface, like a meteorite or something else. But in the future, we might find a better explanation for this strange find. This may sound wicked, but many countries send animals to space before humans follow them. Take Miss Baker, a squirrel monkey, Ham the chimp, and many more. Many of these animals returned to Earth safely and lived happily ever after, like Ham the chimp that lived for 26 years. But some weren't so lucky. Astronauts are still creeped out when they see animals floating in space. Imagine seeing something like that in a dark vacuum. No matter how tough you are, after that, you will be afraid of your own shadow. This may be sad, but it was an essential step in space exploration. The following horror story comes from space engineer Musa Manarov. This guy came across something that made scientists confused. He was shooting a video of space when he accidentally filmed some shiny object flying in the distance. The thing had a cylindrical shape, and Manarov thought it was something that had detached from the spacecraft. But he was unsure because it moved in a unique way. When you think of a creepy space story, the first thing that comes to your mind is some creature crawling on the spacecraft, or some weird object flying in space. But all those things are highly unlikely to happen. When somebody asked Chris Hadfield what the scariest thing about space was, he said it was asteroids. There are thousands of them in space, and the spacecraft is constantly getting hit by them. Chris said that he'd always heard sounds from asteroids hitting his spacecraft. He also mentioned that the spacecraft's solar panels were covered with holes. And you never know whether a giant asteroid will come and hit your spacecraft.